When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice, communities celebrate. Awqaf South Africa, a charitable Waqf receiving organization, makes it easy to share the care. All donations are plowed into Sharia-compliant investments, while the fruits support a great variety of charitable causes. Visit the Awqaf South Africa website at awqafsa.org.za to discover how your Waqf can bless our community with the legacy of care. Awqaf South Africa, share the care. Quality education is a cornerstone of a thriving, prosperous society. However, the South African education system is under strain, necessitating the work of the Awqaf South Africa Education Waqf to help ease the pressure. Our Matric Mathematics upgrade project alone has already impacted the lives of over 6,000 matriculants. At the Darul Arqam High School in Mitchell's Plain, the pass rate increased from 70% to a remarkable 100%. For one student in particular, it was a life-changing experience, with the very first word of the Holy Quran being revealed as Iqra, read. Educating our community is an act of faith. With your help, we can transform many more lives. Awqaf South Africa, share the care.
The care by providing water to water-stressed communities. We share the care by providing eyesight to people that are suffering with cataracts and glaucoma through our cataract removal operation. We bring together youth from all persuasions and creeds through our Awqaf SA youth cricket tournament. What we have observed, though, that and it's been quite alarming, that South Africa performs or South Africa and its education system, and more specifically grade 12 learners, have been performing very poorly with regards to maths. So this is why Awqaf, since 2016, we have embarked on a mathematics upgrade program to assist grade 12 learners that are struggling with mathematics. We really intend through this program for grade 12 learners to perform well in mathematics, and this is a gateway to them attending university and also having a very good career. So since 2016, with the help of Mr. Kota from Kway Mathematics, he has been the tuition facilitator for these sessions. We have gone to centers across South Africa, Cape Town, KwaZulu-Natal, and Johannesburg. We have filled out walls with these contact workshops since 2016, and we've seen some significant improvement. And we have been conducting these online workshops. I think we started last year. It was okay, and we got an overwhelming response during our August 2022 workshop, and we have decided to continue in this vein. And this workshop is for preparation for the grade 12 learners for the final examination. So we wish you all well. So I just want to share with you some house rules. So if you are if you are experiencing load shedding, do not fear. If you drop off the connection, you can refer back to this session. The session is hosted on Awqaf SA's YouTube page. So what you can do is you can subscribe to Awqaf's YouTube page as well as our Facebook page. And I think the easiest way would be for you to visit www.awqafsa.org.za. On our event page, we will have these videos on here so you can refer back to these. So we will never remove these videos. You can always refer back to these videos as well as our August 2022 sessions. We will show that web address later on, so feel free. Connect with us via Facebook, Twitter, LinkedIn, and Instagram. Do post some of your photos of you during the session. Give us your feedback. Let us know what has been some of the highlights or what has worked for you. We really need your feedback, and this will assist us greatly. So without delay, and keep those comments coming in. We'll put that up on screen. Let us know where you are connecting to us from, if you are returning, and how are you feeling? Are you feeling excited about this workshop? So now I'm going to bring on someone very important, Mr. Leonard Madau. He is from the Department of Basic Education, and the department has been a partner for this workshop, and they've been very instrumental in activating lots of the schools. So we're going to bring him on, and he's going to have a message for us. Good morning, Mr. Leonard. The floor is yours. Take it away.
Oh, good morning to everyone. My name is Leonard Madau from the National Department of Basic Education. I'm here to give the words or to revise with you all what we have done through the whole year with your teachers. Revise paper 1 in preparation for you to write well on the 4th of November, which is the coming Friday. We'll revise the whole paper, and we should appreciate the partnership that we have with Awqaf South Africa that is assisting us to revise, to streamline paper 1 and paper 2 today and tomorrow from 9 o'clock to 3 o'clock. So please feel free to ask whatever you don't understand when we'll be presenting. We'll cover all the areas that you are going to write on Monday and Friday. Yes, today we are going to cover the whole topics, paper 1, algebra, patterns, you mentioned them, functions, first principles, calculus, probability, and finance. Then tomorrow we'll look into paper 2 as a whole. So I wish you well. Just know that whatever you'll be learning, it will be great. It will be assisting you to answer very well when we'll be answering paper 1 on Friday. Just know that in mathematics, you should know how to move forward and backwards. Try by all means, if maybe you'll be sketching graphs, how to sketch them, and also know how to derive the equations when graphs are sketched. So I wish you well. Thank you.
So that was Mr. Leonard Endau from the Department of Basic Education. We thank you. Sorry for that echo there in the background. We'll try and sort that out. So we now have a message from Zeinoul Abedien Cajee. He's the CEO of Awqaf South Africa, and he's been very instrumental in this program. So let us hear what Uncle Zeinoul Abedien Cajee has to say.
Dumelang Sanbonani, Goeiemorgen, Assalamu alaikum wa rahmatullahi wa barakatuh. Peace and blessings of the Almighty be on all of you. A very, very warm and hearty welcome to the mathematics class of 2022 and to all those watching this program over our social media platforms. As you know, mathematics is probably one of the most important subjects required for literally any job or profession. Yet South Africa is ranked among the lowest in the world for mathematics education. We are really proud of all of you who have chosen mathematics as a matric subject and also to become proficient at it. We at Awqaf South Africa believe that you have the potential to improve your marks dramatically, as has been shown with previous interventions. Without much ado, we are placing our hope and trust in you. You are the future of South Africa. With a strong knowledge base, excellent moral and ethical values, as future leaders, we pray for your success and in making South Africa the best country in the world. We would like to wish all of the grade 12 learners in the country well in their preparation for the final examinations. We would like to thank parents and teachers who have been involved with providing support to our grade 12 learners. And of course, we'd like to thank the Department of Basic Education for helping us facilitate this program. We'd also like to welcome all the 7,000 participants to this program. Thank you and all the best.
So let's get down to business. So let me introduce Mr. Kota onto the session. Mr. Mohammed Kota is from Kway Mathematics. That is his business. He does maths tutoring and maths lessons. He's been the implementing agent for our maths upgrade program since 2016. We've gone to many schools. And Mr. Kota has a passion for education and, more importantly, mathematics. He eats, drinks, and sleeps mathematics. He's got his education from the University of Johannesburg. We received his tertiary education. And he is essentially the driving force behind Kway Institute. So I'm beaming from the Awqaf satellite office in Cape Town, and Mr. Kota is beaming from Johannesburg, from the Kway Institute. So we're very excited to have Mr. Kota on. You'll find that his method of teaching is quite engaging and quite interesting. So before we call Mr. Kota on, all right, we've got this video here. Let's play this video insert.
We're T-minus 10, 9, 8, 7, 6, 5. We have to go from ready to start. 2, 1, 0. Booster ignition and liftoff of Shuttle Endeavour with NASA.
There we go.
Here we go, Mr. Kota. Are we ready? Are you ready for the launch, Mr. Kota? Are you ready for the launch?
Always. We've launched already. Aye, Captain.
Assalamu alaikum, Mr. Kota. It is indeed a pleasure and an honor again to be doing this maths workshop with you. And we really hope that we're going to have a fantastic class today. So without delay, I'm going to hand it over to you. I am going to be interacting with you, but it's over to you, Mr. Kota.
Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome South Africa, welcome Africa. We're beaming to 10 African countries as well. And welcome to everybody, all 7,000 links. And that doesn't mean 7,000 learners, because we've got some links coming in from schools that got 100 learners in each school. So I'm thinking we're looking at about 20, 30,000 learners for today. Thank you all for joining us. Hello, Litabo. Hello, Muzi. Hello, Byron Kluter. I see a whole lot of new, same learners from our last workshop, and we're going to be having a bumper session today and tomorrow. So I hope everybody is all fired up like we are here in studio here in Johannesburg. So yeah, get your scientific calculators out, be hydrated, and Hassanein, let's take it away, bro.
Okay, so before we get going, let us just put on screen the program. So let's run through the program. Can you see that program on screen, Mr. Kota?
We'll start now. We do some algebra and calculus, and that will take us till 10:30. From 10:30 to 11 o'clock, we'll have a break. From 11 to 12:30, functions and sequences and series. We'll then have a lunch break, and then we'll finish off with finance and probability. And that is maths paper 1 for today. What's required for you guys? Scientific calculator, writing pad, pen, ruler, refreshments, and snacks. No hookah pipes.
Okay. Tell me, that's your class there, your session in there? Who's in class over here?
Yeah, we've got some learners here. We've got some learners. Hello, hello, hello there, guys. Hello. Azara, you can say hello. You can just wave them. Give them a good wave.
Okay, Mr. Kota, take the show away.
Thanks, sir. Good morning, good morning, good morning. Everybody is very excited. We see all the messages coming in. Can we get on with the show? Can we get started? Grade 12s, let's get cracking. Next week, Friday, it's time to meet your Moses. Right. Remember, we've got Judgment Day, Qiyamah for you people next week, Friday. Let's make sure that you are fully prepared. Abigail, Boypelo, Jessica. Hello, Jessica, Kanye, Brent. Hola, hola, hola. Eta. Goeiemorgen. And let's get cracking. Let's clear the frame and let's take the show away. Let's take the show away. Let's choose a color. Guys, I'm starting with algebra. Let's warm you up. I'm not even going to tell you from which papers. So what we're going to do today, we're going to pretend as if this is our paper. Musa, deep breath in. Let's start. The first one, prove. Right. This is algebra, guys. This is algebra. They tell you root 12 plus 2 root 3 plus 3 to the power 1, 5 is equal to root 147 for 4 marks. Take it down, take it down, take it down. So it's square root 12 plus 2 root 3. It's 2 times square root of 3, eh? Plus 3 to the power 1, 5 is equal to root 147. So you guys can start. I'm going to chit-chat a little. You start with it. So I'm going to warm you up with some higher order algebra questions. You guys have all attended our previous Awqaf session where we did our basic to intermediate. Today's intermediate to advanced. I'm not going to do the quadratic formula. So I will do some inequalities today. I'll do the higher order algebra, and then we'll get fired up with our calculus and functions. So come, guys, let's see where you at, where you at, where you at. Hassanein, are we all good there on our back end in Cape Town? How's our Cape Town studio doing?
Yes, we are good. We just seem to be picking up an echo. I don't know if it's from your additional cam picking up the learners.
Yes. Can I kill that camera?
Yes, we can do so. And then at certain intervals,
excellent.
we can
While
have
you
it
guys
going.
are doing this, I'm killing the other camera.
No, it's fine, Mr. Kota. I'll remove it from my side.
Okay.
I'll
Good.
do it. I'll do it from my side. There we go. No more
No,
echo.
just kill my phone.
Okay, there we go.
Just kill a phone. Okay, let's go. No, it's fine. We phone off. How's the echo now?
It's perfect. We don't get any.
Sanine, we there? It's perfect. Now.
Yes, we.
Right.
Yes.
So now square root of
Perfect.
good. They're asking us to prove. So it's algebra, but it's an identity. They want you to prove left-hand side equal to right-hand side. So you cannot bring this onto the other side. You've got to work with the left-hand side separate. So this is going to be the square root of, you want a perfect square times a prime number plus a perfect square times a prime number plus 3 to the power. Now what is 1.5? 3 over 2. There we go. So that is equal to the square root of 4. We left with 2 root 3 plus 2 root 3 plus. Now remember, this is going to be 3 to the power half times 3 to the power. Break this up. This will be 1 plus a half, which is 3 over 2. Now, why did I break it up into 3 to the power half? Because I want another root 3. Yes or no? So this is 2 root 3 plus another 2 root 3 plus this is 3. And then square root of a half is going to be root 3. Very good. So 2 cell phones plus 2 cell phones is 4 cell phones plus another 3 cell phones is 7 cell phones. And that's the simplest that we can get our left-hand side to. Hasanain, are we all good on that side, brother?
Yes, we are.
Right-hand side, the square root of 147 is equal to the square root of 49 times 3. Perfect square times a prime number, which is 7 root 3. Therefore, left-hand side is equal to right-hand side. And that was one of your higher order questions that came out in your paper. Now I'm going to... It was just a warm-up question. I want to show you another one. Now, those of you who attended our grade 12 workshop a couple of weeks ago, right? Our grade 12 workshop a couple of weeks ago, you would have seen this one. So I hope you prepped on the next one that I'm about to show you. Okay. So let's see. Where is that question? I'm just picking it up and here we go. Grade 12s, I hope you guys are enjoying our show. Welcome to the Kway Awqaf show. And that was our opening question. So I hope you guys took the thing down. Guys, we need to pick up pace as well. So if you feel that, you know what, you're writing too slow, rather take your phone, take a screenshot. You can always take it down later if you feel that the problem is too hectic. But the main thing is it when you have time at home. Okay, so here we go. We're clearing the frame. Let's look at the next one. Let's watch this one. Now, this one came out from an IEB paper. Remember, today I'm not only doing for DOE. I'm doing for Department of Basic Education. I'm doing for Sakai, your home learners, homeschool learners, and as well as IEB. Remember, we got to cater for the entire South Africa. Whoever is doing CAPS in South Africa, we are catering for. So, example number 2. Check this one out. Let the larger root of
Question.
Px. Let's see. Let's go back there. What's the question? Please, can you show where the marks are allocated? I'm not going to be able to show you. Look, if it's 4 marks, I'm not going to show you for each step. Remember, you get marks for the entire process, right? You will get marks allocated here, but in today's session, if it we'll only do it in 1 step or test. If it's a 6-mark question, I'll show you how to unpack it. But I'm not going to show you, okay, because remember, different people may use different styles. And all the styles are approved, provided you can justify what you have done, right? Provided you can justify what you have done, you will get a mark step for step. So let the larger root of px squared plus qx plus r equals 0 be capital P. and let the larger root, guys, on this writing pad, I'm trying the best handwriting that I can. Don't fight with me today. X squared plus QX plus PR equals 0, BQ, right? Find the ratio. Find the ratio. P is to Q. P is to Q for 5 marks. Remember, today is here to uplift you. Today is here to educate you. Today is here to gear you. So today's show is not for trolls. So if you're a troll and you want to come here and criticize everybody, get off the show. Get off the show. This is only for those who need to get a distinction next week, Friday, and the following Tuesday. Isa, welcome, welcome, welcome. Assalamu alaikum. We're still getting some latecomers pulling in here into the studio, but welcome, guys. Right, so here goes. This was the one. Answer. I'm also going to give you guys a little time to process the question. I don't want to just give you the answers and spoon feed you. I want you to apply your mind. They're definitely going to be asking you about nature of roots. So after this one, I'm nature of roots question for you. Isa, how's it? You guys good? Nice, nice. Welcome, everybody. Welcome, team. Mr. Madau, these are the learners that he missed his A by 1%. He got 79. He got 79. But he's going to get it now. He's going to get it. I told our Kway students, these are all our Kway students. I told them, I'm expecting nothing under 85%. Don't disappoint me. Don't disappoint me. Right, let's go, let's go, let's go, let's go. Let the larger root. So we're going to start off here with the px squared. So let's call this one equation number 1. And let's call that one equation number 2. Now, in this paper, you know what they did? They actually substituted the simultaneous equations with this. They took out the simultaneous equation and they replaced it with a question like this. So let's see. Let's see. Let the larger root be p. So p is equal to minus b, a root. When they talk about the, so now minus b, so minus q plus the square root of b squared minus 4ac. I'm doing equation number 1. Now many of you might ask, why did I only use plus? Why? What did it say? Let the larger root. That's why I use plus. I didn't say plus minus. Right, Mr. Madau? All over 2p, all over 2a. That's your larger root p. Now let's look at q. And it's not small p. I'm not talking about small p here, guys. I'm not talking about small p. I'm talking about big P. Now let's do Q. Let's do big Q, capital Q. So capital Q is equal to minus B plus, not minus. Let the larger root. If they said let the smaller root, you'll put a minus. Let the larger root put a plus. B squared minus 4AC. The A is 1, don't worry. C is PR. All over 2A. All over 2. Right? A is 1. Now they say find the ratio P is to Q. So what do? We do minus Q plus the square root of Q squared minus 4PR all over 2P divided by, remember ratio means divide. You know what I would do? Let's skip a step. I would tip and times immediately to save time. Instead of divided, I'm going to say times, and I'm going to flip this side. 2 over minus Q plus the square root of Q squared minus 4PR. Are you guys all following me? Let's check the comments. From here, I think you can carry on. Come on, guys. Remember, this whole thing is P. That whole thing is Q. Let's see, what do we have here? obviously that and that is going to cancel out. And that is going to cancel out. So 1 times 1 is 1 over P. And 1 over P represents P is to Q, and that's what they want. So your answer is 1 is to P. P is to Q. Which one? No. Let the larger entire root. They didn't say the nature of the root was. Very good question that came up here in studio. One of the learners asked, why can't I just use the discriminant? No, because they didn't speak about the nature of the root. They said the larger formula. When you're using the discriminant, you're only describing its nature. You're not exactly giving its value. That's why you can't use that one. But good question. I like your thinking. How are we doing in Cape Town there, Hasanain?
Yeah, we are doing well. I've just sent you a message to you.
Let's see. Yes, nobody is here. We are clear on here. Nobody else is online. And we are
so that's
all
good.
good to go. Right.
That's good.
Excellent. Right, now let's give you guys a higher order nature of roots question. I'm not just going to ask you to describe the nature of roots. Right? I'm going to ask you a higher order nature of roots question. So once you guys all get that, tell us how you're doing, guys. Send us all your comments and let's see where you're from. Tell us where you're from and let us give you a shout out to the 30,000 people that are viewing. Let's clear the frame. Right. They tell you the roots of an equation. Take this one down. This is the last one in algebra we are doing. I will then do a higher order inequalities question after this, and then we will go. So the roots of an equation. The roots of an equation are. So now they give us the roots. X is equal to minus n plus minus the square root of n squared minus 4mp all over 2m. Right, where m, n, and p, where m, n, and p in that order are positive real numbers. They also tell us the numbers m, n, and p M, N, and P in that order form a geometric sequence. So they're talking a little bit about sequences and series in this algebra question. Prove that X is non-real. Okay, let's just see. Wait, let me scratch that out. Prove that X is non-real for 5 marks. Let's see. Come on, guys. Guys, I promised you in our last Awqaf session that in our next Awqaf session that you're not going to see the easy stuff. Now, I know Eastern Cape, Northwest, they usually ask, and Limpopo usually ask very tough questions. Now, remember, who's setting your final exams? Your final exams, they are taking examiners, guys. They are taking examiners from all over the country to set your paper. So now you're getting a mixed masala of examiners. So let's see. Hasanain, how's our comments coming in? Are the guys enjoying our show so far?
Certainly, we've got schools from all over South Africa.
The Rona Academy, Gauteng, Neo, Masheo. Hello, guys there. Takalo from Wiseman Tele, Fort High School. Tabo Sihle, Orlando West, Woodhurst Secondary School, KZN, Randfontein, Gauteng, St. Anthony. There's all your shout outs coming in. Kimberly, Aziza, Greenfields in the house. Milnerton, wow. Pretoria Tech, Mashallah.
Check
Well
out
done.
this one.
Namibia.
Nabia.
How's that? Orania Mun.
Welcome.
Swarkop Mun Windhoek in the house. Simania High School, Orlando West. Well done, East London. Okay, enough shout outs. Let's get cracking. Are you sweating already with this one? I've got 1 or 2 learners in my class that already cracked it. It's done. You see the confidence. Mr. Madau, you see the confidence. It's done. I'm done. Right, now listen to me. They're talking about the roots now. So in our answer, we got to start now with delta, right? Delta is equal to b squared minus squared. What is b squared? There's your discriminant, right? So what do we have? We have n squared. So that is n squared minus 4mp, right? So I'm done with that. I'm done with the first part of it. The roots of an equation are, and there's your discriminant, there's delta. Now, because they spoke about roots, now I can use delta. M, N, and P are real numbers, and M, N, and P form a geometric sequence. So if it forms a geometric sequence, we need the common ratio R. So what's your common ratio? P over N equals N over M. Yes or no? What do I have? N equal to MP. Yes or no? So this is equation number 1. That's equation number 2. We now take the MP and we plug it into there. So this is equal to N squared minus 4. What is MP equal to? N squared. What? Okay, it's fine. But n squared minus 4n squared is minus 3n squared. Now, n squared will, remember, what does the question say? Prove that x is non-real. That means we need to show that delta is less than 0, that delta is negative. Now, n squared is always positive. Squared is positive. And a positive times a negative is always negative, which is less than 0. Therefore, delta will always be less than 0. Therefore, the roots will always be non-real. You write it out, guys. These are templates. I'm not doing rough calculation. You can do it exactly the way I'm doing it here. Remember, the minute the question says non-real roots, you need to prove that delta is less than 0. Roots. You got to say that delta is equal to 0. Prove that it's real roots. Delta must be greater than or equal to 0. Irrational roots, delta must not be a perfect square. Rational roots, delta must be a perfect square. So like you can even get an answer like n squared or x squared or 4n squared. That's rational. But the minute you get 3n squared, irrational. You understand? So please learn your nature of roots from grade 11 to apply into your grade 12 scenarios. Okay, guys, that will bring us now to the end. Let me give you guys one more. Let's give you guys one more in terms of nature of roots, and this will wrap up our entire but then I'll give you one more inequality. I'll give you a higher order inequality to do after this. That will wrap up algebra. Hassan, calculus or function. The equations x squared plus rx plus m equals 0 and x squared plus mx plus r equals 0 have equal and real roots. Hassan, you there, bro?
Your handwriting, Mr. Kauter. Take it a little bit easy. Chill
I'm trying.
Pump the brakes.
Okay, wait.
I'm struggling here. I can't see. My eyes is blurry.
The
I'll buy you
equation.
a-
Wait.
I'll buy
I
you a
don't know
blue
what's happening
bull.
here. Wait. We're having a but. Wait, my nub. It's my nub. It's my pen. Can I change my? Okay, I'm rewriting it. Let's start again. The
Nice and neat, Mr.
equations.
Kouter.
Right, here goes. Okay, math, super math. X squared plus RX plus M equals 0. Is that better?
It's still the same.
And
it's like,
X
I'll give you a
squared
gold star today, Mr. Kouter. I'll give you a gold
plus
star for neat
MX
handwriting.
plus R equals 0. Have equal and real roots. Have equal and right. Find M and R if M is greater than 0. Find M and R if M is greater than 0 and R is greater than 0 for 5 marks. The last higher order of your nature of roots and these type of questions. Yeah. We did that, but let's see whether you can, whether you remember it or you do. Hasanain, are you there, bro?
Yes, I sent
My
you a
right-hand
message,
man, my
a private
co-pilot.
message. Yes, I sent you a message for you for your inbox.
Okay, I see. What's our next topic, Hasanain? After algebra?
Let's have a look at the program. Let's bring the program.
There we are.
Okay.
We're doing calculus. Nice. There we go. So the equations x squared plus rx plus m equals 0 and x squared plus mx plus r equals 0 have equal and real roots. Find m and r if m is greater than 0 and n is greater than 0. So let's first start off with delta. Delta is equal to b squared minus 4ac. B squared. Let's look at the first equation here, right? So this here, so we've, that's squared minus 4. A is 1, C is m, which is equal to r squared minus 4m, right? And then they tell you even this one has got equal roots. So delta is equal to b squared minus 4ac. So we got m squared minus 4 into 1 into r. That's a, that's a c. So which is equal to m squared minus 4r. Now, because this has equal roots, this must equal to 0. So r, so in fact, what I can say is minus 4m is equal to minus r squared equals r. This also equals to 0 because it's got equal roots. So m squared minus 4r equals 0. We got m, right? So m is r squared over 4. I'm substituting in here for that. All squared minus 4r is equal to 0. And here, algebra, guys, here comes your algebra. R to the power 4 over 4 minus 4r, 4 squared, sorry, is 16. Donkey Baya is equal to 0. Let's multiply everything by 16. R to the power 4 minus 16 times 4 is 64r is equal to 0. Let's take out r as our highest common factor. I got r cubed minus 64 is equal to 0. That's the difference of 2 cubes equal to 0. R minus 4. This here will be r squared. That will be plus 16. You multiply the 2 minus 4r. Change the sign, plus 4r. So r can't equal to 0 because they said r must be greater than 0. So that r is out. This whole thing is out because you cannot factorize it. Your final answer, r is equal to 4. R minus 4 equal to 0. Oh, you can do that. You can. Okay. Somebody asked, can you say r cubed is equal to 64? R is equal to the cube root of 64. In fact, that's the better way. Okay, do it that way. I just did a different algebra here. Okay, I was a bit dumb. Right, I shouldn't have done that. R can't equal to 0. So don't do that bottom part. Do it like this. Do it like this. From there, move up to there. R can't equal to 0, guys. R cannot equal to 0 because they tell us R must be greater than 0. So that one falls away. R cubed is equal to 64. R is equal to the cube root of 64. R is equal to 4. And there we go. That's our final answer. Right, South Africa? Right. Now we need to get M. Now we need to get M. Let's just check our internet connection here. We've got full. Check your fibers, guys. Check your fibers. Check your internet connection. We're moving on full fiber, full high-speed fiber from our side here. I've got full bars, and there's no load shedding here on our side. So please just check your internet connections if you guys finding any glitches on your side. Check your area network. Check your area network. But remember also, Hassanin, these sessions are recorded as well. Am I correct?
Yes, so this is just something that I wanted to clarify, that if you are experiencing poor internet connectivity, you can always go back to the session after the session, because this is a live classroom, right? And sometimes, depending on your settings, and if you are experiencing poor internet connectivity, you will experience, either audio or visual that's not very clear. So you can refer back to this, later on in the day. You can refer back to this class, and then it will be crystal clear, because this session is dependent on your internet connectivity. All right, Mr. Kota, it's over to you.
Correct. 100%. And Hassanin, the session will also be put up onto YouTube as well, correct?
Well, we are live streaming from YouTube, so it is on YouTube. And if you want to refer back to it tonight, it's on YouTube. If you can go back to it in a year's time, it will be on Awqaf SA's YouTube. And we'll also give that web address. So what you can do is, maybe you can just hop onto the Awqaf SA's website, right? So let's do that quickly. If you hop onto this address on our website, we will be, there is an event page, and on the event page of the Maths Online Workshop, we do have videos of that. So during the intermission, before the intermission, I think I will also flight that on screen. Thank you so much. Over to you.
Excellent. Thank you, Hassanin. Thank you for that. Remember, we solved for R. We now need to solve for M. I'm putting it into here. M is equal to R squared over 4. So that is 4 squared over 4, 16 over 4. M is equal to 4. So we got M is equal to 4, R is equal to 4, and there we go. You will get your 5 marks for that. Okay, guys, send us your comments. Tell us if you guys are enjoying the show and whether you guys are learning a lot today. Yes, Kanye, you are correct. M is equal to R squared over 4. Well done. Kia Fano. Yes, sir. Stay home. Right. Let's go. So you got it. You took it down. Let's go on to a higher, let's do an inequality, right? A higher order inequality. I tell you, 2 over x plus 1 is less than or equal to 6. Let's say 6x Wait. Let's make one up. So I got 2 over x plus 1. 2 over x plus 1 is less than, let's say, 3 over x minus 2. Let's see that. Let's see how we do something like that. Can we do something like this? In fact, we can do 2. We can do this one, and we can do 2 over x plus 1 less than or equal to 5. So there's 2 for you to do. 2 inequalities to solve for x. Zahra, you want to do something? Just go to that TV there on the side and just move it, tilt it a little to the side so even the Madau can see. Yeah, this TV, you can just see if it can tilt a little this way. See? Yeah, tilt it. Can it? No, it's fine. Okay, that's it. Yeah, all right, leave it up like that. It's fine. There we go, guys. Here's 2 higher order questions. Here are 2 higher order questions for you to do. Let's see if you can crack it. Right. Okay. Is this one possible? Is this one even possible? Let's see. 2 over x plus 1 minus 3 over x minus 2 less than or equal to 0. My LCD on this side will be x plus 1, x minus 2. So x plus 1, x minus 2 times 2 is 2 into x minus 2 minus 3 into x plus 1 less than or equal to 0. 2x minus 4 minus 3x minus 3 less than or equal to 0 all over x plus 1, x minus 2. 2x minus 3x minus x minus 7. Oh, this is a nice one to do. All over x plus 1, x minus 2 less than or equal to 0. In fact, you know what, guys? With this one here, you don't even need to do the next one. So now take out minus into x plus 7. We took out the negative sign here. All over x plus 1, x minus 2 less than or equal to 0. Divide by negative. So the negative will fall away. You're left with x plus 7 over x plus 1, x minus 2 greater than or equal to 0. Yes or no? Onliners, are you following me? Onliners, are you following me? Let's see our comments. Let's check our comments. Onliners. Wait, not yet. Nelly. Thanks. No, you don't. Good question. Autumn. No. No, Samia. You don't cross multiply because it's not an equation. You can't cross multiply, please. And you know, this is so important. And thank you for making that mistake. Don't cross multiply ever in an inequality, because you don't want to lose these two. You need the denominator that will help you to do signs. So what are our critical values? I love you guys for making that mistake. Minus 7 is your one critical value. Minus 1 is your other critical value. Plus 2 is your... Now watch what we do. It's 3x values, so we draw a cubic graph. Yes, it's 3x values. So now put it in order. That's my... In fact, let's do this. Let's do that. Let me erase this. Wait, let me draw the cubic graph even better for you. Thank you for making that mistake. Here's your cubic graph. Minus 7 is your one. Minus 1 is your other. 2 is your other critical value. Where is it greater than 0? Where is this graph greater than 0? Doesn't matter. Doesn't matter. Right. So where is it greater? It's above there and it's above there. So you put your one x there and you put your other x there. So x will lie between these 2 points. X less than or equal to -1 but greater than or equal to -7, or to the right of 2. Wait. I'm not yet done. Greater than or equal to 2. But look at your denominators. Can x equal to -1? No. -1 plus 1 will give me 0. I can't have a 0 in a denominator. Take out the 1 equal to sign. Can x equal to +2? No, it can't. So we take out the other equal to sign. And here is your final answer. X less than 1 but greater than or equal to -7, or x greater than 2. If you wanted to write it in interval notation, you could have from -7 to -1 like that, or x greater than 2, 2 to positive infinity. You could have written it like that also. You didn't need to write it in both ways. You could have wrote it like that, or you could have put it in inequality form or put it in interval notation. It's up to you. Whichever one suits you. Whichever one suits. Remember, 3x values is a cubic graph. If it was 2x values, would have been a quadratic. If it's 3x values, it's a cubic. Does it make sense? Onliners, let's hear your comments. Did you guys enjoy this question? Onliners, did you enjoy this question? Now, there was a question under calculus which was even taken out from your prelim paper, and I don't know why. That was such an amazing Otile. Erica. Yes, thank you, Erica. Thank you, Lukman Majam. Loved it, Abu Bakr Ahmed. So now you know what to do, Tasneen Anushka. Now you know what to do when you got 3x values. Let's give you one more. Come on. I know you might be saying, okay, sir, give us one more like this. I'm not going to give you such a heavy one where you're going to do your LCDs. Let's just do this. Watch here. I'm clearing the frame. I'm making it up. Right? I'm just doing it here to assist you. Let's say we say x minus 2, x plus 6 over x minus 1 less than or equal to 0 for 4 marks. Solve for x. Solve for x. We're going to be starting with some calculus after this. All right? We're going to be starting with some calculus after this. We did start with our formalities about 15 formalities took about 10 to 15 minutes. So we might go for break another 10 to 15 minutes later. Remember, our program is just an overview. It's just an idea. We'll try our best to try and keep it to the time. We'll still go for break at 10:30. No problem. But we'll just continue with calculus after the break. Skip a break time because I know some feeding schemes at schools. What? It's fine. Leave it. Let it ring. We don't take phone calls in now. No, it's fine. Yes, it's another cubic function. So what are your 3 critical values, guys? Like I said, we'll still go for break at 10:30 to 11 because I know some of your schools have got your feeding schemes and your food has arrived at your schools. So +2, -6, -1 are your critical values, your CVs. +1, sorry. +1, okay. Yeah, so we're going to do that. So here we go. So put it in order. Your lowest number, -6, then 1, then 2. Less than 0 means below. Where is this graph below your x-axis? Right, it's below your x-axis there, and it's below your x-axis there. So put an x there and put an x there. So x less than or equal to, because there's an equal to sign there, but greater than or equal to 1, or x to the left of minus 6 less than or equal to minus 6. But look at your denominator. Because you got a fraction, you must look here for undefined. Which of these three values make your denominator undefined? The 1. So x can't equal to 1. X cannot equal to 1. So we go here and we take away the 1 equal to sign next to 1. You have to do that, otherwise you'll get it wrong. No, these ones, one will work. You can have 0 over this. You can have 0 over this will give you 0. 2 over this will give you 0. X cannot just equal to 1. You only look at your denominator. Only look at your denominator. I'll check now. Only look at your denominator. Cannot equal to your critical value. Let's see. No, you already factorized. Double animations. You already factorized. It's factorized already. Yes, the cubic graph will... Oh, very nice question. Will the cubic graph always be positive? Yes. So even if you add a negative, watch this. Watch. One negative 1. No. It's not negative 1. Your critical value here is positive 1. Remember, x minus 1 equals to 0. X is equal to 1. Right. So the question that arises, I like that question. Will the cubic graph always be positive? Yes, it will. Watch. Let me show you one. Check here. Even if you add minus x minus 3, x plus 4 over x plus 2 greater than 0 or equal to 0. Watch here. The first thing you're going to do here is get rid of your negative sign. That's why your graph will always be positive. So you'll divide this by minus 1. You'll divide that side by minus 1. So now your question, now it's going to look x minus 3, x plus 4 over x plus 2 will be less than or equal to 0. Your graph is positive. Your three critical values will be plus 3, minus 4, minus 2. So it will still be a positive graph. So what do we have? Minus 4, minus 2, plus 3, less than 0, there and there. No longer greater than 0 because we got rid of the negative sign. So from a negative cubic, we made it a positive cubic. So now you'll have x less than or equal to minus 4 or x less than or equal to 3 but greater than or equal to minus 2. But x can't equal to minus 2. So we'll go next to minus 2 and take away the 1 equal to sign. Does that answer your question? Does that answer your question? Who was that? Who asked that question? Will the graph ever be... Luciana Ricketts. Okay, so that's 4, guys. If you guys are complaining about my handwriting, that's a 4. That's a 4. That's a 2. That's a less than. I'm trying my best. Wallahi, I am trying my best. Okay, so there we go.
Gold stickers today.
Gold stars today. Right.
Gold stars for good handwriting.
Alhamdulillah. Okay, now look here. Start with the calculus. Let's start with the first principles question. I'll only give you one. I'm not going to give you the higher order one that we gave over root x. You're not going to see that. The 1 over square root x. You're going to get either the 1 over x or 2 over x, or you're going to get... The focus is on the quadratic. So come, let's give you one f of x to do. Sorry. Yeah, so this one here, you can just say here, in this one here, x cannot... Yes, undefined. Yes. Okay, so let's clear the frame. Let's give you one. We're starting with calculus. Put the heading there, calculus. Let's start with calculus. F of x is equal to 5 minus x squared. Simple. 5 minus x squared. Find f dash x, find f dash x by first principles. Now, another way they can ask you for first principles, your other instruction for using the formula is what? By the definition of the derivative. Guys, they can try and trick you. They'll use different English. They'll say, find f dash x by the definition of the derivative. It means the same thing. First principles is equal to first principles. It's just different English that they used. Question, answer. We all know, come on, we are grade 12s now. We all know what our final answer is, minus 2x. You need to show how you get it. You need to show how do you get it. Can I just get my coffee there, please? Thank you, Mr. Madau. Mr. Madau is from the Department of Education. He's also sitting in here, and he's the Chief of Mathematics, am I right? Chief of Mathematics sitting in our studio. So we are very privileged to have somebody from the Department of Education. So don't ever ask me a question like, is this allowed? Is this not allowed? Is your method allowed? Is it not? We've got the Department of Education here to either tell us yay or nay, accredit us. So Mr. Madau, are we getting the thumbs up so far in our course? Correct. You should expect this type of question. Did you guys hear that? It's amazing to have the Department of Education sitting in our studio to tell us, are we on the right track or are we not? So we can't have any trolls. The good question is, they asked Mr. Madau, does he have the... He actually has his question. He's got your final exam on his laptop. Did you hear that? Come on, guys. We're starting a fire. 30,000 people, 5 rand. We're sending our banking details. Who's buying the paper? Let's hear our comments. Let's hear our comments. Show us some comments there from South Africa. That's the name. Yes, Mr. Madau. Yes, and he's got your final paper here with him now. Addressed to Shaya Eyes. That was funny. He's sitting right next to me. You saw him. He was here in the beginning. I'll donate 100 rand from 30,000 people. You'll get 3 million rand today, Mr. Madau. That's what they're saying. They're offering you. Right, so let's go. Right, so f dash x. F of x plus h. Let's first do f of x plus h. Don't go into your formula now. Do first f of x plus h is 5 minus x plus h squared. So that's 5 minus. We all know this is x squared plus 2xh plus h squared. This is equal to 5 minus x squared minus 2xh minus h squared. Please do the step first. Don't go into your formula first. Please, I beg you. Don't. You're going to make a big mistake. Now we go. Now write the formula. You get a mark for it. F dash x is equal to the limit as h approaches 0. F of x plus h minus f of x all over h. Right, remember, I can't see all your comments on my whiteboard. I've got to toggle between screens to see your comments. So if there's a comment, I'll appreciate as a name, which you always do, to inform me. There's a question, Mr. Kota. Mr. Kota, are you behaving
Mr.
today?
Varam.
How's my behavior?
Mr. Varam or Mr. Kota? Are you Varam or are you Kout today? Kout as in Afrikaans, meaning cold.
No. Today on fire. And I'm behaving myself. I don't have to get wrapped on my knuckles. I don't need to be told, Mr. Kota, you are being censored here, my bro.
Yes, by the Film and Publication Board here.
So 5 minus x squared minus 2xh minus h squared minus 5 plus x squared all over h. 5 minus 5 will cancel. Minus x squared plus x squared will cancel. Limit as h approaches 0 or tends to 0. Let's take out h. We left with minus 2x minus h all over h. H and h will cancel. Now we say but h approaches 0. Therefore, f dash x. You'll carry on down. I'm just moving to the side because I don't have space. So that's 0. We'll have minus 2x. And there we go. And there we go. You got it right. You got it right. You got it right. You got it right. I'm just having a look at one of our past papers here. Let's see what did they put in under their calculus section. In fact, they didn't even have it in there. Okay. In fact, watch this. Now, one of the questions, listen to me. One of the questions you guys all know from your prelim paper. I'm looking at your prelim paper here. They told you that that question was taken out of the paper, right? They told you, which one was that? Under calculus. Where's your calculus? Where's your calculus? Right. They told you, but remember something. Remember something. So, please, guys, let's do this question here and let's give you some derivatives to do. Before we go on to the higher order calculus questions, let's do some derivatives. Let's do some differentiation. Okay, so let's go. We're clearing the frame there. We're clearing the frame there. Let's go. Y equals, so now y is equal to 3 times the cube root of x minus 4 times the square root of x all over 2x squared. No, not first principles. dy over dx. I want dy over dx. Question number 1. Question number 2. Give me a second. I'll answer your question. Dx. Let's give you another one here. Let's tell you 4 over 3, and I'll put square root x at the bottom here, minus 2x minus 1 over x. Find the derivative. Is worth 4 marks. That one is worth 4 marks. 2 questions for 8 marks. In fact, I want to give you a third one. I want to give it to you as y equals x minus 1 over root x minus 1. And that's for another 3 marks. So 4 and 4 is 8 and 3, 11 marks in total. Remember, you're only going to get 2 in your exam. You're only getting 2 in your exam. I'm just giving you different styles in which it can be asked. In fact, let me just highlight your questions here. That's 1. Let's do the questions in red. 2. Question 3. In fact, let me give you question 4 here as well, the one that came out in your prelim paper. Y equals 4 square root x minus 8 over root x plus pi x cubed. And they want dy over dx. So there's another 4. So you know each one is about 3 to 4 marks. Let's take out your mark allocations. These are just your questions. This year should prep you. If you can master these 4, you can do them all. Mr. Kota. Let's go, let's go, let's go, let's go. There is let's see. How are we doing there, Hassanain?
We are doing well. It's just Mr. Kota.
Alhamdulillah.
It's unanimous.
Cajee.
They're all looking for Hannah. Where is Hannah Montana?
Who was Hannah? Oh, yes. Oh, do you remember? You guys got memories of elephants, bruh.
Yes. Mr.
Yeah,
Kota,
Zahra
you
is here.
must...
Zahra is here. Tasneem Hans is here. Tasneem is here. Okay, let's go. I hope you guys did all 4. Let's see how sharp are you guys. And I hope you guys have been watching our show on TV as well. I know, thank you all. I'm seeing so many messages. We've been watching your live show, Mr. K, on TV. A lot of that has given you prep for today's banger session. Right? You guys have been watching, following us on YouTube. You've been following all our videos, our online prep sessions. Let's go, let's go, let's go. Let's do the first one. Now, I've made all these ones up, right? Okay, that one's from your past paper. That one's from your past paper. Let's do this one. Y is equal to 3x to the power a third over 2x squared. Remember, if it's over one term, that one term belongs to both. Minus 4x to the power half over 2x squared. I'm trying to be American here. You know, the Americans, they warned us about Santon City this weekend. So if any of you don't like your partners, take them to Santon City this weekend. It's a matter of national security, Mr. K. 3 over 2, x to the power a third minus 2. Now I'm going to get banned. I'm going to get banned. The National Security Agency is coming for me. You guys took down the second one, right? I made it up. You have to give it to me, right? I just need space for the first one. Right. Now what do we have? A third minus 2. A third minus 2. So let's go. 1 over 3 minus 2 equals minus 5 over 3. Please don't ask me where does minus 5 over 3 comes from. I'll clap you through the screen. Minus. Remember, so we dividing bases are the same. We subtract the powers. 4 over 2 is 2. X, a half minus 2 is minus 1.5. Minus 3 over 2. Yes or no? Therefore, dy over dx. Now we apply the power rule. That's negative. 3 and 3 will cancel. We left with 5 over 2. X minus 5 over 3 minus 1 minus 8 over 3. Negative times negative is a positive. 2 and 2 will cancel. We left with 3. X minus 1.5 minus 1 is minus 2.5. Minus 5 over 2. Mr. Madau, so we've got the Department of Education right here. Mr. Madau, I know right until 2 years ago or 3 years ago, they always wanted us to write it with positive powers. Do they still want it? Right, very good, thank you. Because I came across a memo last year where they didn't in the final answer, but I know that they minused a mark from the learner. Yes, so thank you very much. I've always maintained that, Mr. Madau, that you got to write your answer with positive powers. You don't need to put it back into third form, but you need to write it with positive powers. Thank you so much. And I'm so glad you are here, Mr. Madau. Please make sure you write your answer with positive powers. Some of your memos leave it with negative powers. You don't do that. They'll mark you down. So don't listen to the memo. You just listen to what I tell you.
Some of the learners want to see Mr. Madau. So we want to see maybe...
Oh, they want to see Mr. Madau. Come say hello to the learners again. Mr. Madau, have a seat, have a seat. Talk to them a little bit. Give them some, tell them, how are you finding the session today? Yeah.
Okay, thanks. Oh, I'm alive. Okay.
Yes, you're live, Mr. Madau. Let us know what your thoughts are on the session and so on. give us some feedback. Some of the learners are very excited that you are present. So give us some feedback and speak to some of the learners for motivation.
Yes, thanks. They can see that no, today's session is totally different from the previous one. We are treating high order questions so that they can gauge themselves as to whether they are fit, ready to write on Friday, paper one.
Mr. Madau, how on point am I with my preparation for them? You saw the paper. You know what final paper looks like. Are we on track or are we not on track?
We are on track. First principle is coming, where learners are expected to use the formula. Is coming, is there. Questions that we have treated just now are related to what they are going to write on Friday. You are perfect on the spot.
Thank you.
Thank you.
Thank you. Thank you. Thank you. This is amazing. You know, this is the first time, guys, this is the first time ever in my 20-year history that we actually had a department official who has the paper sitting with us in the room. I mean, this is amazing. People who are watching us on Facebook and on YouTube and who attended the Kway workshop before, they say, Mr. K, how come I got messages saying, how come we never had this before? Well, there's always the first time, even if it has to happen in 20 years' time. So we really appreciate you being here. We really, really, really appreciate you. Mr. Madau, they say they will make you president if you give them the paper. All right, let's go, guys. Let's go. Enough of the chat. Enough of the chat. Let's do the second. Have you guys took down all the questions? Né? You took down all the questions. Just take down all the questions. Take down all the questions. Tell me, what does question number 2 look like? I made it up. I made it up. So I didn't even take question number 2 out of a past paper, right? But it's a style. It's not about the question. It's about the style and about the technique. Right. Let's do question number 2. What was question number 2? Was it dx? Dx brackets 4 over 3 square root x minus 2x minus 1 over x. So now in your answer, you're going to say dx. Again, do not say equal to. Please, I beg you, that is incorrect. Do not go here and say is equal to. You will get it wrong. Equal to means you are finding the derivative in this style of a question. So what are we doing now? We're now going to say 4 over 3. X to the half will come up to the top as x to the power minus a half. Minus. Now this will be minus 2. Let's do it like this. Let's put this in minus 2x over x. Hey. Plus 1. The minute we separate it, because there's a minus times a minus gives you a positive. This is the catch. Guys, that's why I gave you this one. Because that is your catch in your exam. So dx, we're not yet done, is 4 over 3 x to the minus a half minus 2, x and x will cancel, plus x to the power minus 1. Now it's in a straight line. Now we've simplified it completely. Guys, you know what my heart tells me? Just my heart. That you're going to see something like this. I've seen this in the past paper, man. And something tells me, I'm not looking at your paper, I promise you, Mr. Madau would never do that. I'd love to, Mr. Madau. Wink, wink, nudge. Hint, hint. This is equal to, I got a feeling you guys are going to see something like this. Maybe I'm going to get divine inspiration. Negative times positive is a negative. 1 times 4, 2 goes into 2 once, 2 goes into 4 2 times. So it's 2 over 3 x Minus half minus 1 is minus 3 over 2. Thank you. The 2 will fall away. The derivative of a constant is 0. Minus x. Minus 1 minus 2. This is equal to minus 2 over 3 x to the power 3 over 2 minus 1 over x squared. Please, guys, make sure you answer it exactly the way I do it here. Copy and paste. This is a friggin' template. I can use friggin'. Mr. Kota. I'm waiting for the red card. Red card. How are we doing there? How are we doing? How's our onliners? Come on, talk to us. Send us your comments, guys. Did you guys get this one right? Were you guys bosses at this one? Got it, Piliswa. Well done. You're a boss. Today's session is going to test whether you are ready. How do we know? Good question, Kia Ramderi. How do you know? You only use this when you start applying the power rule. Only when you start finding the derivative. That's the only time you remove the dx and you start using the equal to sign. Good question. That's why it's so important for you guys to ask questions.
I think this is similar to the previous question related to this, where they were simplifying y.
Correct.
They were not finding the derivative.
They weren't finding.
They were simplifying y to get y so that it would be easier for them
to find the derivative. Very good. That's what they have to do. Number one, remember in our previous workshop, we said it's done in 3 parts. BDA. The before part, get it in a straight line. Simplify it till you get it in a straight line. Give us more of your made up ones. No, we don't have time, man. I'd love to sit the whole day and just give you derivatives. No, my darling Envy, Salepi. No, my sweetheart. You have to put it here with positive powers. You have to. It's compulsory. You cannot leave it there. You have to bring it. You do exactly what I do. Do as I do, you will get your 100% in your exam. I will not show you anything unnecessary. I promise you, if there's anything unnecessary, I will leave it out. Everything that I do is necessary for your exams. And we are being rightly guided by the Department of Education sitting right next to me here. Let's do the next one, guys. Let's do number 3. Now, what was this? Number 4, ne? So let's do number 3 first. So y equals x minus 1 over root x minus 1. Question, answer. We need, the minute you see 2 terms, you need to be able to factorize that. So y is equal to, this is a difference of 2 squares. Root x minus 1. Root x plus 1 over root x minus 1. Haha! Never saw that one coming, did you? That and that cancels out. Y is equal to root x plus 1. Y equals x to the half plus 1. We haven't yet differentiated. All we did is we simplified. Now we do the derivative. Therefore, dy over dx is equal to a half x, a half minus 1, minus a half, minus a half. The plus 1 will fall away. So your final answer is 1 over 2x to the power half. And there we go. That's your final answer. And this is not a made-up one, by the way. This one came out in the past paper. You have to. That's the only way you can get rid of 2 terms in the denominator. You have to factorize. Whenever you have 2 terms in the denominator, Your numerator has to be factorized. Compulsory. You can't do anything with it. I want to try something else. Come, let's just have a little bit of fun. We got like 2 minutes left before break. Guys, it's such an amazing show. It's such an amazing session, and time is flying. I'd love to give you guys so much more, but we are constricted by time. And you know what? I really don't have the whole of South Africa who's on my side, because I know if I don't stick to time or if I carry on, everybody's already throwing tomatoes and throwing lettuce at me. They say, please stick to time. Please make sure you complete according to the schedule. You know the trolls, bruh. I don't need to tell you. Trolls are trolls no matter where they are. You always get them. Right, let's do the last. You know what you maybe could have done here? I just want to try something quickly before break. I'm just a bit excited, right? I'm just a bit excited. I'm trying something. Y equals x minus 1 over root x minus 1. I want to try something. How about we rationalize it? How about we multiply it by the conjugate? Root x plus 1 over root x plus 1. Don't write this. Don't write. I'm playing around. I'm having fun. Don't write. So y equals, you're going to have x minus 1 into root x plus 1 all over difference of two squares, right? Root x times root x is x minus 1. that cancels out. Y equals root x plus 1. No problem. Who's the boss? X to the power half plus 1. And we get exactly the same answer. Dy over... Okay, now you can write. Let's scratch it out. Right. Is equal to a half x to the minus. Guys, you get the same answer. So whether you multiplied it by the conjugate or you factorized, you get the same answer. Slatom there, Mr. Madau. Let me see. Touch my blood. Whether you did it by the conjugate, by rationalizing the denominator, I just wanted, I've never doing the conjugate way. This is the first time I'm trying it. But well done. Guys, the energy in our room is electric. I know it's break. I know you guys are screaming. Your stomachs are screaming. Welcome, Mr. Madau. Yeah. Guys, you guys don't know how fortunate you are. I promise you, nowhere in the world, leave South Africa, nowhere in the world are you getting a program like this from China, from Australia to China to UK to USA. You'll never get a program like this, where we're doing a full exam prep and you got an official from the Department of Education sitting in your program. What the exam? Where? Right. Yes, we're going to be doing all of that after break. Guys, after break, our program is going to change slightly. We have to, guys. I mean, there's so much. Dynamics will always change, but I want to be here. I want to make sure that I give you guys the very best in what you deserve. Guys, enjoy your break. I hope you guys enjoyed the first session. It is 10:30 now. We are now cutting for break. 11 o'clock on the dot. I'll see you guys back in session. We got some cubic graphs and we got the optimization coming up. And stay tuned. I got one formula that you can use for all shapes. So stay tuned. Love you guys. See you guys at...
See you guys after the break.
Assalamu alaikum.
We're T minus 10, 9, 8, 7, 6, 5. We have to go from ready to start. 2, 1, 0. Booster ignition and liftoff of Shuttle Endeavour with NASA's final space station crew compartment that brings a bay window view to our celestial backyard.
Welcome, welcome, welcome. Everybody all okay? Are we all good to go? I can't hear you, Hassanain. I can't hear you.
Okay, there we go. Mr.
There we
Kota,
go.
are you ready for the launch? Reloaded.
All good. We had to
Episode
change.
2. Yes, okay,
Segment
don't
2,
worry. We're
episode
going to
2.
hit
I
this
just want to
one
close the
hard.
door. Give me 1
Okay.
second. 1 second. I'm closing the door here.
So while Mr. Kota is sorting that out, we've just repositioned Mr. Kota at another place just so we can get optimal audio. I think there was some feedback.
As you
that,
can see, we
Mr.
changed
Kota's
studios
audio
in
was
30
fraught.
minutes.
So the Mania is back. He's going to do very good handwriting. He is recharged, reloaded, and we're going to hit it hard. Hey, Mr. Kota?
Let's go. Can you hear me clear?
It's
Sound
over to
clear?
you.
Picture clear?
It's clear. We just need to get your whiteboard on there, Mr. Kota, before we get
Oh,
overly
yes. So we need to go to
excited.
StreamYard. Yes, because we had to change studios. Share
Yes, so
screen.
let's get your whiteboard up.
So I learned well from you. Chrome tab. That's it. Boom. I should be live.
There we go, Mr. Kota. It's all
Control
yours.
room. Alhamdulillah.
There we go.
Welcome
Beam me
back.
up,
Welcome back.
Scotty.
I know it was a quick break. You guys have taken this one down. Now, before we went for break, I told you people there was a question in your exam that was taken out. But now I want you to do this one. So I just want to enlarge in that. Let's make that 100%. Let's play around here with our toggles. We've got one of the questions that came out in the past papers is if f of x is equal to minus ax squared plus bx plus 6. Question number 1, the gradient of the tangent to f of x. The gradient of the tangent to f of x at the point minus 1 and 7 over 2. Are you guys winning on that side? Excellent. Minus 1 and 7 over 2 is 3. Show that a equals a half. Show that a equals a half and b equals 2 for 5 marks. Now, guys, this was the very question. That's a 6, not a B. That's a 6. The number 6, that's a B. AX squared plus BX plus 6. How are we doing there, Sanaim? How's our onliners? Talk to us, onliners.
Handwriting. You're going to
this,
detention,
come
Mr.
on.
Kota. You're going to detention,
on.
Mr. Kota.
The gradient of the tangent to f of x at the point minus 1 and 7 over 2 is 3. Show a equals a half, b equals 2. You mean you guys can't read this handwriting? Yo, bruh. Something else, this. Right, let's go. Now, this very question was taken out from your exams. The one that came out in your exam was in the prelim, the graph of g of x equals ax squared plus b over x equal 96 has a minimum value at x equal 4. Find the values of a and b. They told you people, they removed that. It's the same as this. How do we do this? That's your question. That's your answer. Okay, so they give us a point here, guys. They give us a point. That's x, that's y. Let's now go and put it in. So where's my calculator? We're going to need our calculator for this. I'm putting my calculator here next door. So let's go. Let's put in the y. 7 over 2 is equal to minus a into x is minus 1. X is minus 1. Minus 1 squared plus b into minus 1 plus 6. Guys, that's the best handwriting I got. I cannot write any clearer than this. And if you can't read this, yo, we are in big problems. 7 over 2 is equal to minus A into 1 minus B plus 6. So let's multiply everything by 2. Okay, wait, let's first remove that 7. That's 7 over 2 is equal to minus A minus B plus 6. So let's multiply everything by 2. So 7 equals minus 2A minus 2B plus 6 times 2 is 12. So minus 2A minus 2B is equal to 7 minus 12 minus 5. Ne? There we go. So in fact, if I divided everything here, so I've got 2A. If I divided everything by negative 1, I get minus 2A plus 2B is equal to 5. And there we go. That's equation number 1. That is equation number 1. Now they tell us the gradient of the tangent to f of x at that point is equal to 3. So the minute they say the gradient, so now f dash x, the gradient, is equal to minus 2ax plus b. That's your gradient. The power rule, the derivative, minus 2ax plus b is equal to 3. And we got x. X is how much? Minus 1. Minus 2a into minus 1 plus b is equal to minus 3. 2a plus b is equal to minus 3. And you know what? We need to solve for a and b. In fact, I'm going to take this one and put it here. I'm going to put here minus 2a minus 2b is equal to minus 5. So even leave this one out. You don't even need that one. I have taken this one because I'm going to add these two equations. So plus 2a minus 2a is 0. Plus b minus 2b is minus 1b is equal to minus 3 minus 5 is minus 8. Hey, what happened here? We need to get b is equal to 2. Plus b minus 2. So what happened? Did I make a mistake here somewhere, guys? Did I make a mistake? Minus b plus is equal. I put minus 3. Sorry, there's my mistake. Picked it up. Picked it up. Picked it up. Boom. We all human, bruh. So 3 minus 5 is minus 2. B is equal to 2. There we go. B is equal to 2. And now let's show that A is equal to a half. I can go 2A plus B is equal to 3. B is equal to 2A plus, what is B? What is B? 2 is equal to 3. 2A equals 3 minus 2, which is minus 1. No, 3 minus 2 is 1. 3 minus 2 is 1. So therefore, A is equal to 1 over 2. Whew. A is equal to a half. There we go. There we go. A is equal to a half. B is equal to 2. And there we go. Let's hear our onliners. Did you all get that one right? Did you all get that one right? Do you know how to do it? So let's just break this one up for you. So all this part here, from here coming down to there is part number 1. From there coming to there is part number 2. Part number 3 is your simultaneous equations. We solve there. And part number 4, we solve for A. So we solve for B and we solve for A. Do we all have that? Let's hear our comments. Let's see what our audience has to say about that. Lukman Majam, yes, sir. Yes, sir. Well done, well done, well done, well done. Okay. Now, obviously, you're going to get now, let us now do a cubic function. Let's get an equation of a cubic function. Let's ask you a whole lot of questions about a cubic function. And then we'll go on to calculus application, volume and total surface area. So let's clear the frame here, guys. I hope you've taken it down. Take a screenshot. I hope you took it down. Let's go on to the next one. So take this graph down. Take this graph down. So here goes. So we got that. We've got that. And let's say we have a graph going like this. That is graph F. I give you that turning point there. I tell you that is 4 and negative 10. I tell you this point here is 1 and 20. And I tell you that point there is 18. So I now also tell you that f of x is equal to x cubed plus ax squared plus bx plus c. Right, question number 1, find a, b, and c. Find a, b, and c. Question number 2. Question number 2, I want the average gradient. I want the average gradient between x equal 1 and x equal 4. Question number 3, for which values of x is the graph increasing? For which values of x is the graph concave down? And where is f of x? Right, so we got f of x, right? We got f of x, and I'm now going to give you another graph, another straight line called graph G. I'm going to do it in a different color, and I'm going to tell you that G is there. So that's graph G. So where is f of x divided by g of x less than 0? So this is graph F, that's graph G. Now, mark allocations, 6 marks. Average gradient between the 2 points, 3 marks. Increasing, 1 mark. Concave down, 3 marks. And this one here, f of x divided by g of x, 4 marks. Total marks, 6 and 3, 9, and 1, 10, and 3, 13, and 4, 17 marks on this graph question. We're then going to go into optimization after this. I'm going to talk to you guys about the graph. And immediately after this, we are then going to go into optimization. And we're going to do functions till our next break. Let's see. Onliners, how are we doing? Hassanain, how are we doing there in Cape Town? Talk to me, bro.
We are rocking. We are sitting here on Clifton Beach. And
Oh,
we're having
nice.
an ice cold beverage. But by the way,
Nice.
we do have a request here. I'm just putting that up on the screen from Miss Olivier.
Yeah.
Mr. Kota.
Could you please ask Mr. K to do one where they give you a y-intercept and 2 turning points with coordinates 2 and -30? It's exactly the same. Bronadine, this question that I'm doing now with you is exactly the same as the question that you're doing. So hopefully if you can do this one here, you can crack them all. So come guys, I'm going to give you a couple of seconds. All of you, I know you are prepared for your exams already. I know you are prepared for your exams already. I want you to try this one. I'm going to give you about 3 to 4 minutes or even 5 minutes to finish this up. I'm just going to take a quick, because we move studios, Hassanain, if you can give me a 3-minute bathroom break and I'll be back to mark this with everybody. Are we all good? I think you can keep some chit chat going. Give me a 3-minute bathroom break.
Not a problem.
Thank you,
Not a
boss.
problem. Okay.
Wa alaikum salam. How are you? Alhamdulillah. Good, good. Who are you?
Dear learners, thank you for your positive comments, feedbacks. We're trying our level best to sort out some of the gremlins in the system. So Mr. K should be having a little bit better audio output. Some of the learners are experiencing issues with, perhaps the screens being blurry. And so you must bear in mind that we are transmitting a video content, Mr. K's whiteboard and his video. So if you are experiencing poor internet connectivity, there are certain areas across South Africa that do experience poor internet connectivity. Do not despair. What you can do is you can stay on for the class, for the duration of the class, and once the session is done and over, then you can refer back to it, and then your screen or your internet connectivity, when you're on your area that's got good internet connectivity, you will be able to view the session properly. Some learners will be experiencing some blurry screens. It's because you have got poor internet connectivity. We've got lots of the settings over here that's optimized for internet at 360p at a very low range. So let me share some information with you while we're waiting on Mr. K. That please, we've received some of your photos of your sessions. Kindly do send us some of your photos, how you are linking up with your peers, yourself, with your notes, your refreshments, your beverages, while you are watching the session. At Awqaf SA on Twitter, Instagram, Awqaf South Africa on Facebook, and we'll also give you our email address. The other important thing is that we are hosting a competition. The competition, what we want to do is, and we will email all participants, and this competition and the link will be open only after your final results has been released. We want you to upload your July results as well as your final results once you have written your paper, and we want to find out if indeed these workshops have benefited you. There are cash prizes available for the first position in terms of the top mathematics results, first, second, third place, and most improved. So that email communication will be coming to you from our side, and of course that link will be open after the final examination, and all winners of the competition will be announced telephonically or via email. So there are cash prizes available, and we do have a portal, a link that you can upload the PDF or JPEG of your July as well as your final results. So Mr. Kota will be joining us shortly. He's just on a comfort break. So let us know in the comments if you are enjoying the session. And I think Mr. Kota is back with us. Mr. Kota, welcome back. Okay, so we're just getting ready for Mr. Kota to hop on again.
Yeah, back.
Welcome back, Mr. Kota. I'm sure with
Thank
that
you.
with that comfort break, the handwriting is going to be optimized, the brain power is going to be optimized, and you're going to take us to another dimension.
I got my energy drink.
Mr. Kota, they are not paying
I'm
us.
closing it. I got my energy drink.
Yes, they are not paying us for any of these endorsements, Mr. Kota. So
I know. That's
not
why
sanctioned.
I'm showing the back of the.
Yeah, but that's good enough. You know, I don't know.
That's good enough.
I don't know.
Let's go.
Okay, over to you, Mr. Kota.
So, Mr. Madau, remember something, I'm sitting right next to your examiner. Right, Mr. Madau, we've got two graphs here. We've got two functions. We've got a cubic graph with two turning points. Right, let's answer question number 1. The first thing you do is you find the derivative. You find the derivative of the original. So we're going to go f dash x is equal to 3x squared. Guys, you'll never get this again in life where your matric examiner is sitting right next to us. 2ax plus b. The power rule, and that is equal to 0. Now, the first thing you need to do, guys, listen to me. After you do that, cancel that out and cancel that out. You're not going to be using the y's. So now we're going to do, we can call this one turning point 1, SP1, and let's call this one SP2. So we're going to do simultaneous equations here. So we're going to do 3 into, let's do SP1, 3 into 1 squared plus 2a into 1 plus b equals 0. So we got 3 plus 2a plus b equals 0. Why do we equate it to 0? For minimum or for maximum? So now we got 2a plus b is equal to minus 3. And that is equation number 1. We're now going to use the second stationary point. 3 into 4 squared plus 2a into 4 plus b equals 0. So 4 squared is 16. 16 times 3 is 48 plus 8a plus b is equal to 0. So we now have 8a plus b is equal to minus 48, and that is equation number 2. We know what c is already. C is equal to 18, your y-intercept. So basically, we're only solving for a and b. So now I'm going to take this a plus b and put it here. I'm going to say 8a plus b is equal to minus 48. And now we're going to subtract the 2 to cancel out the b's.
Yeah, I think it's best to label the equations. That is equation number 1.
Equation number 1, equation number 2. There we go. So that one will be equation number 1. That one is equation number 2. Let's subtract. You can do it by substitution or elimination. I'm just doing it by elimination. So 2a minus 8a is minus 6a is equal to minus 3 plus 48 is minus 45. So a is equal to 45 over 6. 45 divided by 6, 15 over 2. Let's double check our calculations here. 2a plus b equals minus 3. 8a plus b is equal to minus 48. Let's put the 2. 2 minus 8 minus 6 plus b minus b 0. Minus 3, I'm going to do it again manually to double check. Minus 3 plus 48 gives me plus 45. So obviously a will equal to minus 15 over 2. A is equal to positive divided by a negative. Remember, we got 45 over minus 6 minus 15 over 2. Now we want b. So let's put it into equation number 1 if you want. So we got 2a plus b is equal to minus 3. 2 into minus 15 over 2 plus b is equal to minus 3. The 2 and the 2 will cancel out. B is equal to minus 3 plus 15. So what is b equal to? 12. B is equal to 12. A is equal to minus 15 over 2. And C is equal to 18. So let's write it here. A equals minus 15 over 2. That's a 15. Somebody will complain about my handwriting. That's a 15. B is equal to 12. C is equal to 18. Right, Mr. Madau? Excellent. Take this one down, guys. Take this one down. How's our onliners doing? Come, our 18,000 onliners. Let's hear you and see you. Let's hear what you have to say.
That was a big gulp there, Mr. Kota. I thought you were going to swallow us
I
in there.
need all the energy I need, bro. I need all the energy we can get today.
But you need to sleep early tonight, Mr. Kota, so we can get the best of you for Maths Paper 2 tomorrow.
Ooh, tomorrow, compound and double angles is going to be fire. Tomorrow is going to be fire. More fire.
I'll be your selector and you'll bring the fire.
I'm telling you. I'm telling you. Okay, guys, I hope you took it down. Can I erase it? So now what you do, guys, do me a favor. The minute you found A, go to A, go to B, go to C, and go and change it in your original. Minus ax squared minus 15 over 2x squared plus 12x plus 18. And there we go. There we go. Average gradient. You know the word average gradient. Let's answer question number 2, guys. Let's answer question number 2. The average gradient, y2 minus y1 over x2 minus x1. And I'm sitting with past papers from all the different provinces here. So I'm choosing all the stuff you need to know. So the answer to question number 2, we've done number 1. So average gradient is equal to y2 minus y1 over x2 minus x1. So between x equal 1, between that point and this point here. So let's say y2 minus y1 over x2 minus x1. So this will give me minus 10 minus 20 minus 30 over minus 3. And minus 30 over 3 is 10. Over 3. What's happening with my science today, Mr. Madau? What's happening with my science today? So our gradient is negative 10. That's the average gradient between the 2 points. Now, for which values?
It makes sense. Look at the shape of.
Correct. If you want to double check, it's negative. So what you can do, change in y over change in x. Going down is negative, going to the right is positive. Negative divided by positive has got a negative gradient. So you know you're right. It makes perfect sense. I think Mr. Madau should join me on all our road shows and all our road trips. I'm so happy you are here today. I hope you're going to be joining us for the whole session today. 2:30 we gone, so don't worry.
Big ups to Mr. Madau. Big ups to Mr. Madau.
Yeah, big ups to Mr. Madau. Guys, what you say tomorrow till 5 o'clock? They'll be screaming, no way, Mr. K. No way. We will never do it till 5 o'clock. Right, we've answered question number 2. Let's go to question number 3. Where for increasing or decreasing, you look at the original graph. Now, let me teach you. Let me show you how to do increasing or decreasing. If you don't know, all you do is you draw tangents. Watch here. Draw a tangent there. Draw a tangent here. And draw a tangent there. Now we know this here is going in this direction. So it's got an increasing. This one's got a decreasing gradient. And that tangent has got an increasing gradient. So draw gradients. Draw tangents. So for increasing or decreasing, I want you to draw tangents. And then check the sign. Check where it's positive or negative. Positive, negative, positive. So they want increasing. They want positive. So where is it positive? From negative infinity up to 1. Or you could say x less than 1. or x greater than 4. X greater than 4. So from 4 to positive infinity. There we go. There we go. That's where it's increasing or decreasing. You look at your original graph and you draw your tangents. Did you know that? Did you ever do that in school?
Question.
What if we are not given a graph? If you're not given a graph, you look at you find your turning points. You find you can see what are we dealing with increasing and decreasing. We are dealing with our 2 turning points. So if it's a positive graph, your lower value, it will be increasing from negative infinity up to your lower turning point, and from your higher turning point to positive infinity. You just work out your turning points. I hope that helps you. Sometimes I'll show you something quiet after this. Sometimes they give you the derivative graph and they ask you where is your original graph increasing or decreasing. I'm going to show you that just now. Concave up, concave down. We know that is our point of inflection. So second derivative. So I'm answering question number 4 now. Just remind me, I need to draw the derivative graph for you. Sometimes they give you the derivative graph.
Question.
Question. Both. Jade, this is for everybody. This is for everybody. This is for DOE, IEB, and Sakai. Question number 4. Concave down, second derivative. So f dash x is equal to 3x squared minus 15x plus 12. That's your first derivative. F double dash x is equal to 6x minus 15 equal to 0. 6x will equal to 15. X will equal to 15 over 6. X is equal to 3 goes into there 5 times. 3 goes into there 2 times. X is equal to 5 over 2. That means, watch here. There's your derivative graph, f dash x. Your 2 points are 1 and 4. This point here is your x value of your turning point, your second derivative. F double dash x is 5 over 2.
Question.
Let's see. How do we work out the turning point? Power rule. Power rule. Derivative. Turning point is always derivative. So your first derivative is turning point. There. That's your turning point, your first derivative. And then you equate it to 0. Then you factorize and you find your 2. You'll get 1 and 4. Remember, turning point is first derivative. Second derivative is the turning point of your derivative graph. So now, here it's concave down. There it's concave up. So concave down. The question says, the answer to question number 4, concave down. Concave down is from minus infinity up to 5 over 2. Do not put a square bracket, because that there, the derivative here will equal to 0. To find out the turning point, you use first derivative. Let me write it out again here on the side. To find your turning point, you use first derivative equal to 0. And then equal to 0. Sorry, they couldn't see that in the corner there. Let's take that out. Let's say is equal to 0. And then you factorize, then you solve for x. That's how you find your turning point. The second derivative. The second derivative is finding concavity. And another word for second derivative is your point of acceleration. And first derivative, another word for it is velocity or speed. First derivative is velocity or speed, ms to the -1. Acceleration, ms to the -2, second derivative. Right. Now let's see. Where is f of? Let's answer question number 5. Now question number 5 is the one that kills all of you. So far, so good. Onliners, are we okay? Let's hear your comments. Schools, teachers, principals, professors. If you write, sir, if I write x less than 5/2, no, you'll be right. Tiani, no problem. X less than 5/2, you'll be 100% correct. Let's go, let's go, let's go. So let's take all this out. Let's take all our writing, all our scribbling, all our notes. Let's take all that out. Let's now answer question number 5. Oh, they're already asking what time is break. Imagine, what time is our next break? 12:30. That's the name?
Let's have a look. Let's have a look. Let's have a look.
Because I think they're ordering food from Mr. Delivery. So they want to tell Mr. Delivery when to deliver.
1:45.
1:45. 12:45.
That's the big one.
Okay, there we go. Now, this is a very, very interesting question. It could be worth 6 marks also. They could make it higher order and make it 6 marks. We got our graph F. We got our graph F. We need the equation of graph G. Graph G's equation is our straight line. G of x is equal to mx plus q. We don't have m, we don't have q. But we got 2 points, right? We got 2 points. So we know, listen to me, we first need the equation because we need to know what are our x-intercepts. So we can't do it without getting our equation. So let's do this first. This is a higher order question. That's 18. And that the x value there is 0. Right, Mr. Madau? Right, good. We're answering question number 5. You need to pay real attention here. They don't give you the equation of G. We need both graphs equations. We got the one equation. We need the other equation. So here goes. Here goes. Let's go. Remember, I'm not working from a memo. We are all doing it together. I'm answering it as if we are all writing this in the exam together. So watch this. I want to find out what is the equation of G. So I'm going to go y minus y1 equals y2 minus y1 over x2 minus x1. Y equals mx plus c. Did you guys ever see this formula before from analytics? Do you remember y minus y1 equals m into x minus x1? So if you wanted to go and first find the gradient, then use y is equal to mx plus c, you could, no problem. Otherwise, use this formula. So let's call this, x1, y1. Let's call this x2, y2. So y minus y1 is equal to y2 minus y1 over x2 minus x1 into x minus x1. Now we bring it in the form y is equal to mx plus c. Learn this. I love this formula. It's just my way of doing it. So y minus y1 is equal to mx plus c. Y minus y1 is equal to mx plus c. So y minus y1 is equal to mx plus c. Y minus y1 is equal to mx plus c. Y minus y1 is equal to mx plus c. Y minus y1 is equal to mx plus c. Y minus y1 is equal to mx plus c. Y minus y1 is equal to mx plus c. Y minus y1 is equal to mx plus c. Y minus y1 is equal to mx plus c. Y minus y1 is equal to mx plus c. Y minus y1 is equal to mx plus c. Y minus y1 is equal to mx plus c. Y minus y1 is equal to mx plus c. Y minus y1 is equal to mx plus c. Y minus y1 is equal to mx plus c. Y minus y1 is equal to mx plus c. Y minus y1 is equal to mx plus c. Y minus y1 is equal to mx plus c. Y minus y1 is equal to mx plus c. Y minus y1 is equal to mx plus c. Y minus y1 is equal to mx plus c. Y minus y1 is equal to mx So y minus 18 is equal to minus 10 minus 18 is minus 28. Minus 28 over 4 is minus 7. Into x minus 0 is x. I take the 18 onto the other side. Boom. Bob's your uncle. Minus 7x plus 18. We don't think we right. We know we right because it goes through 18. So now we have our equation of this. And this is the fun of math. That's why I love it. Math is my passion because you can always check whether you are right or wrong. So we don't think we right. We know we right. So we got y is equal to minus 7x plus 18. Now we answer this question. Now I don't know what method you guys use at school or what method you've been shown. I'm going to teach you a strategy. We're going to have lots of fun answering this question. Watch. So I hope you took it down. Onliners, are you enjoying it so far? How's my onliners doing? Give us some feedback.
They're focusing. They're focusing.
You are
They're focusing.
focusing. You are focusing.
Yes. Refocusing the lens.
Right. Love you guys lots. Inshallah. Inshallah means God willing. You guys all going to get your distinctions. We're going to clap that paper. And remember, I'll tell you before our next break, we got another session next week, Thursday, next week, Saturday. Day before you write paper 1, day before you write paper 2. I'll put up all the details later before break. We start at 4 o'clock in the afternoon on Thursday, right until 9 o'clock at night before paper 1. And Saturday from 9 o'clock to 3 o'clock, even till 5, even till 8 o'clock at night for paper 2. That is our commitment to you. So we got another session coming up as well. But obviously that won't be free, but it'll be a small charge to it. Unfortunately for that one, we are not sponsored. But yeah, stay tuned. Stay tuned. I'll give you all the details before break. Like I said, Thursday and Saturday, paper 1, paper 2. Let's go, let's go, let's go. Let's erase this. You got this. You're liking it. You're loving it. Now let's answer. Now pay attention. Right. Now right here. F of x divided by g of x less than 0. Now we all know less than 0 is negative. What will give me a negative? A positive divided by a negative will give me a negative, or a negative divided by a positive will equal to a negative. So let's do the first one. Where is f positive? Where is f positive? Where is f above your x-axis? Now, obviously, you needed to find out here in graph f what your x-intercepts were. So let's say, for example, that was -1. Let's say that point there was, just for argument's sake, let's say that point there was 2. And let's say that point there was 6. Just for argument's sake. So where is f positive? F is above your x-axis between, and let's make it equal to, let's make it less than or equal to 0. So between -1 and 2, that's where f is positive. Between -1 and 2. You draw a number line. Where else is it positive? Greater than 6. That's where f is positive. Remember, guys, I'm doing this. Where is f positive? Where is g negative? G is negative for all your x values. G is negative for all your x values greater than 2. Greater than or equal to 2. Now to construct your inequality, I want you to do this in the exam. They don't show you this in the memo. They only give you your final answer. I want you to use this strategy. Remember, we are doing this first one here. We are doing the first one there. Where's F positive? There we go. Where is G negative? There we go. Because a positive divided by a negative will give me a negative. Now, divided or multiplied. Divide or multiply means where do they overlap? So where do these two inequalities overlap? Do they overlap here? No. Do they overlap there? This and that? No. They only overlap there. So your first inequality, x greater than or equal to 6. That's your first inequality. We're done now with that one. We still need to do this one. Your memo will only give you your final answer. You won't know how they got it. Let's see if you guys can do the second inequality on your own. Do number 2. Option 1, option 2. Do option 2 the way I did option 1. And let's see how sharp are you. Exactly the way I did option 1. I want you to do option 2 to see if you get the second inequality. Now, many of you also cried with that hotel question. Many of you cried with that hotel question in the prelim exams. I'm going to do that one for you guys today. The one with the 72 rooms. Onliners, how are we doing there? Love you guys lots. Like I said, next week Thursday, next week Saturday also. Paper 1, paper 2. We're here to crack it. We're here to get a distinction, guys. Destination distinction, not destination pass. Okay, let's do the second one. We done the first one. Let's check whether you got the second one right. So Mr. Madau is sitting next to me and he's also doing it. Mr. Madau, let's check whether your answer and my answer is the same. Right, let's do it. And this is the way you can answer. Please show all calculations in your exam. So where is F negative? We're now going to see where is F negative. F is negative. All your x values less than -1. F is negative also between 2 and 6. Right? That's where graph F is negative. Now, where is G positive? All your x values, watch here, all your x values, where is G positive? Above your x-axis. For all your x values less than 2 to infinity. Are you smiling? Onliners, are you smiling? Are you seeing? Right, where do these two overlap? Do they overlap here? No. Do they overlap there? No. Where do they overlap? They Did you get the same answer? Well done. That's it. You see, me and Mr. Madau, we're sitting here and we are competing against each other also. Because we're not sitting with memos. It's a different thing. We're sitting with memos and we're copying the memos. No, we're not sitting with memos. We're here to understand what we are doing. Not copy and paste, Baba. No copy and paste here. Learn this. How many of you got it right? Holla us. How many of you got it right? Rotondwa. Mafangu. Well done, well done, well done, well done, well done, well done. Congratulations. Okay, fantastic, fantastic. Now, some of them, sometimes your teachers show you the number line, some of them show you the table method, Some of them show you how to interpret it. Just do it this way. I like this way. You can do it any way you want to do it. You can do it any way you want to do it. But if you like my way, use my way. You like your teacher's way, use your teacher's way. I'm not here to say you have to use my way. Right. Let's now go into, all right, I wanted to show you that one there. Let us talk a little bit about your derivative graph, which I've come across in many of your papers. So what they do in the exam, they give you that, they give you this, they tell you that is f dash x. Now they give you this point here as 2, they give you that point there as 6. Let's ask you some questions on this. Question number 1. Question number 1. I want the x values of your turning points, TPs of f. I want the x value of your point of inflection. Question number 3. Where is x increasing? Where is f increasing? For which values of x is f increasing? Where is f increasing? Where is the graph for which values of x is it concave up? Find the derivative. Mark allocation. 2 marks. 2 marks. 2 marks. 2 marks. 3 marks. Total. 2 plus 2 is 4, 6, 8, and 3, 11 marks on this. 11 marks on this question. That's your question in your exam. We're going to be doing the answers on the side. After calculus, according, what did you say? After calculus, we're going to be doing functions. Am I right? Hassanin?
There we go. It's on the screen now.
Let me see. Let me go. Let me check. Let me check. Yes, function sequences and series. Hey, I've got some cracker functions and cracker sequences and series and sigma notation coming up. Right, guys, let's answer this together. Let's answer this together. Answer to question number 1. The x values of the turning points. Now, the x values of the turning points are your 2x intercepts of your derivative. So, x is equal to 2. You read it directly off here. And y is equal to 6. The x value of your point of inflection. So now we want this value. There's your point of inflection. POI. Now, how do we do that? 2, 3, 4, 5, 6. That means there's 4 units. They are 4 units apart. Divided by 2, because we want the halfway mark. So it's equal to 2. 2 units this way or 2 units that way. So 2 plus 2 or 6 minus 2 is how much? 4. Your answer is 4. Your x value of your point of inflection is, so you'll write here, point of inflection 4 and y. What? Oh, sorry. We did it. Thank you. X equals 6. Sorry. Thank you. They sharp. You also didn't pick it up. We both didn't pick it up. Okay, sharp. I made a stupid mistake. X equal 2 or X equals 6 for that. Thank you, thank you, thank you. We are human beings, Baba. We are human beings. The point of inflection is the halfway mark here between the 2 points. Sorry? Correct. You could even add the 2x values and divide by 2. So 2 plus 6 divide by 2. 2 plus 6 is 8. 8 divided by 2 is 4. So we're done with question number 1. We're done with question number 2. Where is f increasing? Now, let me show you something. Your original graph is going to look like that, right? In fact, let's do this. Your original graph is going to look like that. Your one x value here is 2. Your other x value here is 6. Where is f increasing? Here's it. So you look at, for increasing or decreasing, you look at your original graph. Remember we said that before. So it's increasing for x less than 2 or for x greater than 6. It's increasing there and it's increasing there. You can draw a rough graph, or you can look on your derivative graph. Check here. I show you something quiet. You could have done this, or the second way, you could have looked at where your derivative graph is positive. Where is this graph positive? It's positive there and it's positive there. That's where your graph is increasing. Because this graph represents your gradient. So where is your parabola? Where is your gradient increasing? Less than 2, greater than 6. Onliners, you following me? Are we
Yes.
good?
Excellent.
Number 4. Where is the graph concave up? So we look at this graph here. So this was 4. Remember, our point of inflection was 4. Our point of inflection was 4. Concave up, x greater than 4. Let's do the last one. Find the derivative. That means they want another way. They basically find the derivative. They want the equation of your parabola. Because your parabola is the derivative. Your parabola is your derivative. That is your gradient. That is your derivative. They want the equation of that. Let's do it. Now you do what you do in functions. When you are given 2 x-intercepts, what do? We're answering question number 5 here. So we go y equals x minus x1 into x minus x2. Y equals x minus 2 into x minus 6. That's your derivative, huh? This is f dash x. F dash x. That's your derivative. Your parabola is your derivative. X squared minus 2 minus 6 minus 8x. We FOIL it out. Minus 2 times minus 6 is plus 12. Boom. That's your derivative. That's the answer to question number 5.
We're cooking with gas,
Okay.
Mr. Kouter.
G?
We're cooking with gas here.
We on fire here. We are on fire. We on fire. Now we're gonna have fun. Now we're gonna do calculus application. Now I'm gonna teach you guys one formula you can use for all your standard graph, for all your volume and total surface areas. All right, watch. So let's do what we call optimization. Please learn this formula. You're gonna need it. So we're starting with calculus optimization. So your optimization, there are 3 parts, 3 types that you could see in the exam.
Question.
Where is the A value? No, you can assume A is 1, or at Tilway, you can assume A is 1 because no other point is given on your graph. You don't need to put A, only if another point is given on the graph.
Okay.
I'll show you that when we do functions. You just go x minus x1, x minus x2. Don't worry about A. You can assume your A is 1. Optimization is volume and total surface area. The second one is graphs, graphic, where they'll give you a graph like that, and they'll give you a graph like that, and then they'll give you that, and they'll tell you to find the maximum distance between the two graphs, like that. I'm just showing you what it could look like. And the last optimization now is a graph. In fact, now you're going to get a story. They like stories, you know. Maths, they like stories. So the story could be speed, acceleration, or it could be cost versus price. Cost versus product. Like the example, the hotel example that they gave you in the prelim exams that hit you guys. You know, Conor McGregor and Khabib, it hit you. You had to tap out. Many of you tapped out for this one in your exam. Let's first start with this. I'll do an example here, an example here, and an example there. Or maybe we might not do all. We'll see how much time we have. Hope you guys enjoying the show. I hope you guys enjoying the show.
Question?
Yes. Let me see. I came across a first degree polynomial where they want me to prove the values of A, B, and C if I work backwards, almost like the antiderivative, but would I get full marks for it? You can't use the antiderivative because that's not also going to be part of your curriculum. You can't use the product, the chain rule. You can't work backwards unless you're using the formulas, unless you're using derivative equal to 0, which is your first derivative moving backwards. Right, Bronadine? Okay, let's get back here. Let's get back here. Now your total surface area for all your standard shapes. So now what are your standard shapes? Your standard shape is a cube. Your standard shape is a rectangular prism, a block or box. Your standard shape is a cylinder. And your other standard shape is like your Toblerone box, your triangular prism. Okay, so these are your standard shapes. Now for a closed top, so say the top is closed and the bottom is closed. Closed top, closed bottom. Closed bottom, closed top. Closed bottom, or closed top, closed bottom. So for a closed top and bottom, closed top and bottom, we got two bases. So total surface area is 2. Where does the 2 come from? Top and bottom, top and bottom, top and bottom. 2 times area of base plus perimeter, PER, of base times your height. So 2AB plus PBH. Just remember that total surface area is 2AB plus PBH. Now you can adjust this formula for all the different shapes. If the area of a base is a square, length times breadth. The perimeter is a square, then you can say length times breadth, or perimeter, it would be 4 times side, or you can say side plus side times side. If it's a rectangular prism, area of base, length times breadth. Perimeter, 2 times length plus 2 times breadth. Area of base of a cylinder, pi r squared. What's the perimeter or the circumference? 2 pi r. 2 pi r is the circumference or the perimeter of a circle. If it was a triangular, area of base would be half base times perpendicular height within your triangle. Perimeter of base would be side plus side plus side times your big height. So remember this formula. Now sometimes the top is open and the bottom is closed. Please read your question carefully. Now total surface area will be 1 times area of base, common sense, because you only got one base, plus perimeter of base times height. So you can see we're just adjusting that formula. And if it was open on the top, let me just draw it again. Let's say you had a circle and you had a circle and it was open on the top and open at the bottom. Now total surface area, there's no bases. So you just say perimeter of base times height. So you just manipulate this formula for all your standard shapes. So just remember TSA, 2AB plus PBH. 2 times area of base plus perimeter of base times your height. Give me a second. They're talking quite loudly outside. Sorry, guys. You know, we in South Africa, we scream when we talk, bruh. It's a South African thing. We stand next to each other, but we say, how's it, man? We want the whole world to hear.
Amplified.
We are amplified. We are loud. South Africans are just loud by nature. Then we go to other countries and we see everybody is quiet and we're wondering what is wrong with you. They think what is wrong with us, Baba.
Maybe they're on mute, Mr. Kway.
Huh?
Maybe they're on mute.
I'm telling you. I'm telling you. Okay, so here goes. Let's clear the frame. Let's clear the frame. Okay, so here goes, guys. Let's do one where they give you right. So they give you this. Take this one down. Take this one down, and then I'm going to choose another one. So they give us that as x. They give us that as 300 minus x. We have done this one in the previous workshop. Let's see. Find the volume in terms of x. Find the volume in terms of x. This is an easy one. Then we're going to do the graphical one. We're going to do the graphical one, and then I'm definitely going to do the hotel model for you. Find the volume in terms of x. Find x giving maximum volume. Find x for maximum volume. Find the maximum volume. Find the total surface area if the cylinder is open on the top. Using the x value from question number 2. Ha, nice. So now they're telling us find the volume. Okay, so they're telling us it's open on the top, but it's closed at the bottom. So it might be like a brandy glass, right? Or a drinking glass, or a cylinder that's closed on the top, but a reservoir. It could be a reservoir, right? Something that stores water. So say that was the reservoir. That's a reservoir. Something that South Africa is deeply in need of. More reservoirs. Load shedding, water shedding, petrol shedding, brain drain. This country needs a good injection, bruh. That's why it's you guys. You are the future. You are the ones to take us to the next level. You'll make me your president. Make me your finance manager, finance minister. We'll tell Praveen he must just move aside. Right, come guys, let's do it. Find the volume in terms of X. So we're answering question number 1, volume of a cylinder. You got to know pi r squared times height. Pi, I'm going to use 3,14. R is X squared. My height, there's my height, 300 minus X. That will give me 3,14 X squared into 300 minus X. Now that times that will give me 942 X squared minus 3,14. X squared times X is X cubed. Units cubed. You must put units cubed. Number 2. Onliners, how are we doing there? Away. Yeah, math shading is level 8, brah. No, for your standard shapes, they don't give you total surface area. They'll only give you the total surface area. Listen, Mamela, open up your ears. Luister mooi. Almal. They will. No, the measurements is in calculus. The person who asked, we don't see measurements in paper 2. No, this is part of your calculus. Optimization. This is paper 1. Now hear me and listen carefully. I forgot what I was going to say. Let's go. Yo, you guys get me spinning here. I even forgot what I was going to say. Right, whenever they
just
say
take a deep breath.
maximum, yeah, it will come back to me. It will come back to me. Find X giving maximum. So whenever you see minimum or maximum, derivative, dy over dx. So here we got dv over dx. So power rule, 1884x minus 3 times, that's going to be 9,42x squared. For minimum or maximum, your derivative is always equal to 0. So now we need to solve for x. So whether you want to take out x, I would take out 9,42x as my highest common factor. Now that divide by that is 200 minus that divide by that is x is equal to 0. So 9,42x will equal to 0, or 200 minus x equals 0. X is equal to 0 over that is 0, or minus x is equal to minus 200. X is equal to 200. Now x can't equal to 0. So obviously 200 is x giving maximum. Therefore 200 is x giving maximum volume. Now what if they ask for minimum volume? Will you go and put 0? Never. Why? Because 0 will give you 0. No shape can have zero volume. So 200 is minimum or maximum. You must take both the x values, plug it into the original. Whichever one gives you a higher positive volume, that is x giving maximum volume. Sometimes your lower x gives you maximum. Sometimes your lower x gives you maximum. Because sometimes when you substitute your higher x value, you get a negative. And you know you can't get a negative volume. So please substitute both. Sub both x into original. And what do you want to get there? You want to get a positive, a higher positive volume or area or total surface area. Right, the next question, find the maximum volume. So let's answer question number 3 here on the top. Question number 3, what are we going to do? We got 942x squared minus 3,14x cubed. So here we go. We're answering question number 3. Volume is equal to 942x squared minus 3,14x cubed. We now got x 200. So volume equals 942 into 200 squared minus 3,14 into 200 cubed. Your answer is 1256000 units cubed. Right, onliners? Now let's find the total surface area. Let's now find the total surface area. Using x from 2. Right, let's answer question number 4. Now they don't give you, it's not on your formula sheet and they don't give it to you on the side. Assume that they don't give you a hint on the side. Normally they'll tell you a hint. No hint. Total surface area equals 1 times area of base, because I only got one base, plus perimeter of base times height. So area of base is pi r squared, plus perimeter of your base is 2 pi r, and your height is 300 minus x. So that's pi x squared, right? So let's just make that an x. Let's go. Let's have fun. Let's have fun. So what do we have? Pi 3,14. Your r 200 squared plus 2 times pi times 3,14 times 200 into 300 minus 200. Because they told you use x equal 200. Let's go. Calculate the time. 3,14 into 200 squared plus open brackets 2 times 3,14 times 200 close brackets open bracket 300 minus 200 is 100 times 100. Boom. And we get a positive answer. We get a positive answer 251,200. Boom. Bada bing, bada boom. Bada bing, bada boom. Final answer. Right. Any comments? Let's check our comments coming in. How are you guys doing? Onliners. How are we doing?
In focus
18,000
mode.
learners online. Are you focusing nicely? Are you learning well?
Focus mode.
Are you learning well?
So how's the weather in Johannesburg, Mr. Kota?
It's cloudy today. Lovely weather. I wouldn't lie. Nice weather. We're expecting some heavy storms, but it's just cloudy. No rain. I heard you guys getting some sunshine there in Cape Town.
Sunshine, and we are in Clifton and Sea Point Beach,
I
soaking
know,
up
I
the
know.
sun.
Bantry Bay,
We
here
do
come,
that every day, Mr. Kota. After work, we work hard and we go to the beach. We
Stop
jump in
showing
the
off.
water and we soak up the sun.
Stop showing off. We don't want to hear about Cape Town. We don't want to hear how good Cape Town is. We starting a
trying to
campaign
be-
to show you how Joburg is better than Cape Town. Did you guys see that video
I
that went
know.
viral about the cherry that said, "Yo, at Cape Town, I'm the most beautiful woman in Cape Town. Cape Town's got the most beautiful woman, most beautiful beaches. Everything's grand about Cape Town." Lies. Everything's grand about Joburg. I'll show you how quiet Joburg is.
Yeah, you guys got a
I'll face
beach
you.
there in Johannesburg, in Pretoria.
Yeah,
So
yeah,
yes,
yeah.
it's definitely a good place.
I stayed in Cape Town for 5 years, so I love Cape Town too. So Cape Town's my other home.
My condolences.
Right, guys. So there we go. That was our question on this. Let's give you one with a graph, guys. Let's give you a one with a graph where they give you something like this and they give you something like that. And then you remember the one that they gave you? They gave you like this, and then they gave you a point here, and they call that point P, and they call that point B, and B was 0 and 3, and they told you that this is graph F, and they tell you that F of X is equal to what was it? 3x squared plus 1. 3x squared plus 1. Something like that. Or even just x squared plus 1, whichever it is. Right, find the maximum length of PB. Find the maximum length of PB. Sorry. For 7 marks. I'm going to do this one and then I'm going to do the hotel one after this. There was one, guys, I want you to work through your past papers. I'm just showing you today, I'm doing some examples, showing you how it's done. We'll do some other examples again, if you guys joining us next week, Thursday and Saturday. There was one in the past paper, I don't know if you remember that. There was a hill. They gave you a hill and they gave you a small kariki there. They gave you a kariki there. And they say the car was running out of petrol. And they wanted you to find out whether the car will reach the top. Now, unfortunately, we don't have enough time to do that one today. There's so many different styles, but I need to show you how it's done. So please, guys, join us next week, Thursday, next week, Saturday as well. And we're doing it at a discounted rate for the entire workshop.
But Mr. Kauter, you're not giving the full information and you might be creating confusion. Is it an in-person workshop happening in Johannesburg? Is it an online workshop? You know, just give opportunity at a certain time. Yeah, so please, let us rather, I would rather us at a certain point of the program where you give the full information and not create
I will put down, Hasanain, I'll put down all the information on the screen before break.
Sure.
So guys,
thank you very much. So we have full information.
I will give you guys
this is
all
an exclusive Kway program. Oh, don't want to have unnecessary admin coming in through the Awqaf office.
Got nothing to do with Awqaf. Yes, correct. 100%. Guys, don't flood Hasanain's inboxes and finding out when is the workshop, when is the workshop. No, relax. I'll give you all the details before we cut for break and before we leave today. Okay, so let's go here. Let's go here. Let us crack this one. Now, the first thing you need to do, and the reason why I'm doing this to show you, the minute they don't give you a value here, you need to call that value X. They don't give it to you, you call it X. And the other value there is your Y value, which is F of X. And what is f of x? They give us f of x, 3x squared plus 1. So that's your x value, that's your y value. Now they want length or they want distance. Guys, we got 20 minutes before break. We got 20 minutes before break. I want to finish this. We'll come back from break. I'll do functions and then I'll do sequences and series. I think probability will just carry over into tomorrow morning. Right, so let's go. So we want the maximum length. So do me a favor, PB squared. Don't say PB is equal to the square root. You won't be able to find the derivative. So PB squared is x2 minus x1 all squared plus y2 minus y1 all squared. So PB squared is equal to x2 minus x1 squared plus y2 minus y1 all squared. Right, Mr. Madau? Madau or Mudau? Madau. Okay, so here we go. PB squared is equal to x squared plus, this will be 3x squared plus 1 minus 3 is minus 2 squared. So PB squared is equal to x squared plus, let's remove the brackets here, guys. That would be 9x4, multiply the 2 times it by 2, minus 6 times 2, minus 12x squared plus 4. So PB squared is equal to x minus 12x is what? Minus 11x squared. So let's put it in order. Wait, let's put your highest, let's do it from highest to lowest. Let's go 9. So here's 9x4. So 9x4, that's x. X minus 12 minus 11x squared plus 4. Now we want x to give us maximum length. So we say dpb squared over dx. 4 times 9 is 36x cubed minus 22x is equal to 0. For minimum or maximum, the maximum length is equal to 0. So let us take out x. What am I left with? 36x squared minus 22 is equal to 0. So x is equal to 0 or 36x squared. Is equal to 22. X squared is equal to 22 over 36. X is equal to the square root of 22 over 36. So the square root of 22 over 36. And that gives you, put it as a decimal, 0.78. 0.78. So that is x giving you maximum. Now you want the maximum length. Therefore, maximum length is equal to, we're going to plug it where? We're going to plug it there. So therefore, PB squared, therefore, PB squared will equal to 9. So I'm going to plug the 0.78 into there. So let's go. 9 into 0.78 to the power 4. Minus 11 into 0.78 to the power 2 plus 4. 0.6389. 0.6389. 5504. I'm just going to write the whole thing out because I want to be as accurate as possible. So therefore, PB, you only find the square root in your final answer. Is the square root of that. So the square root of 0.63895504 Boom. 0.799. 0.799, which is about 0.8. Now, it could be in meters or kilometers or whatever unit they gave you. Let's say they told you it was kilometers. So the maximum length would be in kilometers. And there we go. I hope you guys enjoyed this one. It did come out in a past paper. Whenever they give you any function and they don't give you an x value at a point, call it x and the y value is the function value. They must give you the equation of the graph. How are we doing there? How are we doing there? We got 15 minutes left. Let's do that one about, let's do the one from your prelim, man. Let's do the one from your prelim to wrap up calculus before break. Asamin, how are we doing there? How's our onliners? Are they focused? Are they paying attention? Our 20,000 learners.
We are hungry. We want lunch, Mr. Kauta. Buy us lunch. What's for lunch?
15 minutes. Yeah, you know Riyad Musa, what he say? 15 minutes, boss. 15 minutes.
Oh, I've heard
Every
that
charo
before.
says 15 minutes. How far are you? You could be 2 kilometers. You could be 2 hours away. 15 minutes, boss. I'll be there.
No, it can't be a charo. It must be a maro.
Right. So you guys got this. You guys got this. You guys got this. Let's clear the frame. Let's see if I can remember. Right. I don't even have it. Mr. Madau, do you see me having it in front of me? Nothing. Let's go. Let's see what that one says. A hotel has 72 rooms. They charge 500 rand per night. If the rental is increased by 100 rand per night, 2 rooms are left vacant. If x equals your rate per night, and x is greater than 500, show, now I think this is the one where, show that your income is equal to, oh my God. All right, I forgot that equation. I remembered the story. I know it's something with the 82. Wait, blom. Here's it, 82x. All right, I had to have a backup here, guys. 82x minus x squared over 50. And calculate the maximum daily income per room. So question number 1, show that, and then calculate your maximum daily income. Calculate your maximum daily income. Rate per night or your daily income. This was your daily income. Are you guys ready for this one? Are you ready for this one? This one was worth 5 marks. That one was worth 2. So this is a story sum. So let's see. Let's go to StreamYard. How are we doing, onliners?
We are cooking with gas.
We've got now a couple of minutes to go. I hope you guys are enjoying the show. Give us a thumbs up. Send us an email. Hasanain will put his email address. Phone Hasanain or phone the Awqaf. Tell them how much you enjoyed the show. And if you need more of the... okay. I don't think you would need it. I think you're all going to get distinctions, inshallah, for this exam. So I don't think you're going to need this again for this year. But I think you guys are going to be sharp. Don't worry. I got you. I got your back. Kway and Awqaf, we got you. Right, let's go. Let's crack it. So 72 rooms. So let's put rooms. We got 72 rooms. Our daily rental is our normal rental. Our normal rate. Our normal rate is how much? 500 rand per night. So 72 times 500, your income is there. So 72 times 500. 72 times 500 is 36,000. That's what you will get on night 1. Remember, on night 1 or on day 1. From night 2 onwards, from night 2 or from day 2 onwards, read the question. The rental is increased by 100 rand per night and 2 rooms are left vacant. So your rooms available are no longer 72. It's 72 minus 2. Right? Your rate per night, you're going to have to take X, where X is your rate per night, minus 500 divided by 100 rand, because it's increased by 100 rand. So let's say if you wanted to find out on what day are you, so let's say you were paying 1,200 rand per night. So obviously you're going to take 1,200 minus 500 is 700. 700 rand divided by your increase by your 100 will give you 7. That means you are on night number 7. Makes sense, right? So here's a formula. This was the difficult part. For you to derive a formula for your rate per night. Your rate per night minus your 500 divided by 100 is going to give you on what night you are. So what will income be? What will income be? Income will be X into 72. That's what we want to find. Show that I. So this is I, your income. Your income is X into 72 minus 2 into X minus 500 divided by 100. That's your income. Because they're telling you X is your rate per night. So say you were paying 1,200. 1,200, you got 70 rooms left over. And then 1,200 minus 500 is 700 divided by 100 is 7. So 70 times 7 multiplied by 1,200. And that's how you would get your answer. So let's go. X into 72 minus 2x over 100. Here, Mr. Madau, here's that same thing like we did in derivative. Remember, because we're taking out the brackets, we say plus. Right? 2 times 500 is 1,000 over 100. Okay? All right? So here goes. Here goes. Here goes. Somebody asked us to re-explain this. No stress. Follow the process. 2 nights were left vacant. So 2 rooms were left vacant. So 72 minus 2 is your rooms available. To find out on which night you are or on which day you are, you take your rate per night minus your 500 rand per night divided by your increase per night. So your total income would be X into your available nights, there's it, available rooms, multiplied by your which night are you staying in. So minus 2x times X is minus 2x over 100 plus 500 over 100. Let's go again. X into 72 minus 2 over 100 is 1 over 50. X over 50 plus 100 divided by 10. Why am I dividing by 100? Because it's increased every night by 100. So we divide. 100 divided by 1,000 is 10. 72 plus 10 is 80. I'm moving over to the side because I don't have space. I'm moving over to the side because I don't have space. So I'm moving over here to here. So income is equal to X into 72 plus 10 is 82 minus X over 50. Let's multiply that out. 82X minus X squared over 50. Boom. And there we go. We've got 6 minutes left before break. We got 6 minutes before break. There's your income. We've answered question number 1. Let's answer. You can now go ahead and answer the maximum. So now you're going to have to find the derivative here. So let's do the second one here. I'm just erasing the question. Onliners, how are we doing, guys? How are we doing? Income equals 82x minus x squared. I'm going to make that 1 over 50. So income, it's already in a straight line. So di over dx, 1 times 82 is 82 minus 2 over 50 is 1 over 25x equals 0. And here we go. We're going to calculate now our maximum income. We're now calculating our maximum income. Mr. Madau, how we did this one? Nice, ne? Minus 1 over 25x is equal to minus 82. That and that will cancel out. X is equal to 82 times 25 on this side times 25 on that side. That and that will cancel. 82 times 25. This is X giving maximum income. Is that what's the question? Find X giving maximum. They didn't say find the maximum income. Ne? Yes. So 82 times 25. 2050. Rand per night. There we go. The maximum amount that this person can charge in 1 month, he can't go more than 2050 Rand per night in a month. Okay. This was also the one that we did in a live show on TV last week, Thursday evening, if you guys watched the show. Okay, we've got about 3 minutes. Hassanin, I'm just going to put up the details for next week's show, for Thursday and Saturday. We're wrapping up now before break, guys. I'm just putting up the details.
Can you see the screen, Mr. Kota? I have assisted you by putting up the date and the contact details. So
Thank you. Kway program, online and in person. Thank you so much. I just want to put the pricing and then people can WhatsApp me directly for the booking. All right. So Thursday, I'll give you guys the times now. Jazakallah so much, Hassanin. That was sharp.
Can you explain?
That was smart.
But can you explain? Is it in Joburg? Is it in Cape Town?
Yes, I'm going to do all that now. We're beaming from Johannesburg. Guys, we're beaming from Joburg and we only have 20 live seats. But don't worry, you guys can join online. So this is the live seats. Online, you guys can join. You guys will WhatsApp me on my number 081-706-3986. But don't do it today. Do it by tomorrow or Monday when our link goes live. Our link should go live by tomorrow, right? There is a cost involved, and it's Thursday, and I'll give you Thursday and Saturday. So Thursday, we're doing paper 1. Saturday, we're doing paper 2. Thursday, we start from 4 p.m. to 9 p.m. Saturday, we start from 9 a.m. until 3 or 4 p.m. You tell me, right? I'll go until 5 if I want, if you guys want me to. The cost involved for each day is 180 Rand per day. So you can book for 1 day or you can book for 2 days.
Is it online or offline?
Online and live. I'll send them the
Okay.
links. So it's online and live, and I'll be broadcasting from Auckland Park. Take this info down, guys. I'll give you guys this info again at the end of the show. We'll be broadcasting live from Auckland Park. And guys, this, like I said, this is a paid, so you can work at home, you can work at your school, wherever you're going to be working from. This is not a sponsored program. This is a private Kway workshop, and all Q&A, hopefully by Saturday, by Thursday evening, 9 p.m. will be completely done. Every humanly possible scenario we would have completed, and then Saturday as well from 9 o'clock to 3 o'clock. Guys, if you're loving the show, take all these details down, take a screenshot of it so you've got all our info. Jazakallah to Hassanain for putting it up as well. This info will stay up during the entire break. It's break now. Hassanain, tell what time do we reconvene?
So let's pull that screen up for us quickly, so we know what's happening. So there we go. So we reconvene again at 1:15.
We've got we've only got 30 minutes. Guys, we're a little bit over. All right, so 30 minutes, guys. 30 minutes. Remember, we're finishing off at 2:30 today. So we're doing functions and sequences and series after break. Guys, enjoy your break. Love you guys lots and hope you guys enjoying today's session. Jazakallah Awqaf, Jazakallah learners. See you guys at 1:15 p.m. Enjoy your break.
So these are some photos from some of the learners as they have logged on to the session.
Oh, nice. Beautiful. Of all the kids around the country, these are live photos that came in. All of them all sitting and doing their work from their home and from schools. Wow.
Look at the focus and dedication.
Amazing. Amazing. How nice. We've
Oh,
got
Mr.
the whole
K,
country.
You're on TV, Mr. Kota, but that's a photo of me.
Yeah. Alhamdulillah. Alhamdulillah. You know, this was my dream about 10 years ago from Cape Town, where we were going to use Stellenbosch, University of Stellenbosch and telematics. We were actually considering beaming, but that would have meant getting a specified, dedicated DSTV channel. There were too many logistics, and the online platform has just boosted us into the 21st century. And here we're teaching the entire country, one teacher. Alhamdulillah. And teachers, no need for teacher training now. We join all these workshops and give us your comments. If you like the way we're doing it, you want us to do questions, and you'd like more of these seminars going forward, let Awqaf South Africa, Hassanain's our man. If he can't do it, Hassanain, he's our man. He can't do it, no one can. Enjoy your breaks. Assalamu alaikum.
Yes. Okay, Mr. Kota, get some rest there. We'll speak to you on the other
I
side.
need a little
Thank
bit
you
of
so
a
much.
comfort break too. I'll see you at 1:15. Assalamu alaikum.
Thank you. No, salam. So guys, while Mr. Kota is muted and he's taking a break, feel free to send us an email with your feedback. If you are beaming from a school, you can send us a lengthy email, a testimonial, what you're enjoying of the session, how can we improve, and what aspect of this workshop works well for you, and of course, how we can improve it, and also send us some photos. Your positive feedback will ensure that the subsidized program continues. So I'll also be logging off. We will be putting your comments on screen at the moment. And yeah, we will resume again at quarter past 1. Thank you. Right, Mr. Kota, you might have to unmute yourself. I think your mic is on mute.
On mute.
Oh,
There we go. There we go.
Mr. Kota back in the house. Hope that you got a chance to rest your voice box.
Hey, I was speaking to Mr. Madau now. Are we live? Are we live? Are we live?
Yes, we are.
Okay, I was speaking to Mr. Madau now, and he's saying that we are sitting on over 200,000 viewers, guys. Over 200,000 viewers nationally. Been getting calls, been getting some WhatsApps here. We back. So I don't think we're actually breaking our own record. I think last time we had about by the time we were done, between 30 and 50,000, and we're sitting with about 250,000 at the moment. So yeah, guys, you guys are part of a world record-setting, groundbreaking, paradigm-shifting initiative. Welcome. And I hope you guys enjoyed your break, and you guys also had a good lunch, and you guys are now fired up for our last session. Now, guys, we're going to be doing functions and sequences and series, finance and probability. I'm going to have to carry over into tomorrow. We're going to be focusing on the functions and sequences and series. Tomorrow is paper 2. I'm hoping that we can finish off at 3 p.m. tomorrow. I'm just requesting. I don't know whether everybody's okay with it. Maybe they can give us a thumbs up. I don't know what their transport arrangements are from schools or whatever the case may be. But thank you, Luandile. The pressure is kicking in there, Clement. Ibrahim Ali, Alhamdulillah. Welcome, everybody. Luazi, Onaten, Jarkanda, Anam Dlovu, Lebohang, France, T-Flame, Kaylee, Avery. Welcome, guys. Okay. We are back. Try and make an arrangement for 3 p.m. tomorrow, guys. We're still going to keep to the same program, but I'm going to be finishing up all the work. Remember, we're going to be doing every single topic. Last push, Baba. Last push. Let's get started. Before we went for break, just to remind you guys, next week Thursday, next week Saturday, paper 1, paper 2. Here's all the details. And here's the number to WhatsApp. Hassanin will also put it on before we leave today. Right, 0817063986 is the number to WhatsApp. If you guys want to book for next weekend, 180 Rand per day. And we start 4 p.m. to 9 p.m. on Thursday and 9 a.m. to 3 p.m. next week, Saturday. Online and live. Live, we in Auckland Park. We only have 20 seats. But online, we've got unlimited. So we'll be broadcasting here from Johannesburg. This is a private Kway workshop. It's a Kway initiative. Please do not contact Hassanin. Don't flood his inbox and don't flood Awqaf. Hassanin, when will today's session be uploaded onto YouTube for them to watch, to review? I had lots of inquiries asking about today's session. Some of them who missed some of the parts today. So I just want to know, maybe
Mr.
you can give us
Kota, if I can just share some information with the participants.
Yes.
The session, as it is now, if I go onto YouTube, it is on YouTube, right? So it's not a case where I have to upload something to YouTube.
Oh,
the session is live on. I'm just going to share a screen with you. And the moment we end the session, right? Let me just do this here quickly. The moment that I press or in this live stream, it will be on. I'm just going to show this. There we go. So I don't know if you can see my screen.
There we go. There we go. Yes, I see that.
So that's the Awqaf YouTube page, right?
Oh, I see. So it will be on the Awqaf YouTube page as from immediately after the session.
Immediately at the moment, it is on the. Let's have a look here. You see, this is the Awqaf. This is the Awqaf YouTube page.
Right.
And you see under videos, under live, This
Right.
session, Maths Paper 1, it's on the Awqaf YouTube page.
Excellent.
So you don't have to do
Excellent.
anything. All right.
Excellent.
So do not fear.
Thank you so much.
The session is here. The revolution will be televised. Over to you, Mr. Kautar.
Alhamdulillah, Alhamdulillah. Jazakallah, Jazakallah, Jazakallah. Let's get started, guys. I'm starting off with a graph like this. I'm doing this. Oh, wait. Let's go here again. We are now doing functions. So I'm giving you a graph like that. And I give you another graph coming down here. I give you a point here. And I'm going to change this point. I'm going to call this point P. I'm going to call that 0. I'm going to call this point R. And I'm going to give you a point here, 4 and 2. Right. This graph on the top is graph G. So this is graph G. And this here is graph F. Right. So they tell us f of x is equal to the square root of kx. And they tell us that g of x is equal to log ax. Right, guys, we're dealing with functions. We back in, we back in, we back in. Question number 1. Where is f of x greater than g of x? Question number 2. Find k and a. Find k and a. Question number 3, the inverse of f. They want the inverse of f in the form f of -1 equals. Let's ask you another question. They want where is, let's make up a question here for you. Where is g of x greater than 0? Where is g of x less than or equal to 0? And A, B, C, D, E, F. The next question, sketch f of -1x. Right, here goes, here goes, here goes. In fact, I can give you another one. Question G. I want the asymptote. I want the equation of the asymptote of G. The equation of the asymptote of G. Let's go. This comes out of a past paper. This model comes out of a past paper. Let's crack this together. Right. The first thing we need to identify, we need to study the graphs. We know that this graph goes through this point here. We know that's a log graph. We know G, graph G is a log graph, and we know that point is 1 and 0. It's a no-brainer. It's a no-brainer. We know that this graph here, graph F, whenever you see square root, it's the inverse of a parabola. Right, so this is the one with a restriction. With a restriction. So where is f of x greater than g of x? Let's answer the first question. So where is f greater than means above? So where is f above g? So obviously for all these values, right up till 4. So for x less than 4 but greater than 0. So that is the answer for the first question. Where is graph F above graph G? For which values of x? B. Find K and A. How are we doing, onliners? Talk to us. Schools, I know you guys been sending us pictures of your schools. You're sitting in schools. You're working so well. Alhamdulillah, it's just heartwarming, tear-jerking to see all the learners at all the different schools sitting and working together as a collective. Must say congratulations to all you two. Perpetual, how did I get the coordinates of R? All standard log graphs have only one y-intercept. You know your exponential graph has only one x-intercept. Exponential is 0 and 1. A log graph is always 1 and 0. Always. Because if I put log of 1, when x is 1, check on your calculator. Put there log 1, what will you get? You'll get 0. So it's a no-brainer. It's something you need to know. I hope that answers your question, Perpetual. I love your name. Yesterday, my Uber driver was permission. Let's answer, find K and A. So you got y is equal to root kx. So we got a point on the graph. 2 is equal to root k. What is x? 4. 2 equals root 4k. Let's square this side. Let's square that side. So 4k is equal to 2 squared 4. K is equal to 1. K is equal to 1. So that means you have root x. So K is equal to 1. Your final equation here is just root x. F of x is equal to root x. K is equal to 1. Find A. Find A. So y equals log ax. So you got log A. What's your x value? 4 is equal to your y value, which is 2. So it's log A4. Now, many of you don't know what to do here. Many of you do not know what to do. So we use what I call the smiley face or the winky eye method. The winky eye method. And where do we start? Here's your smiling face. That to that is equal to this. To drop the log. So you say a to the power 2. A to the power 2 is equal to 4. So therefore A is equal to 2. So we use the smiley face or the winky eye method. There's your smile. Your base to that power is equal to that number. So there we go. A squared is equal to 4. Without the log, this is standard form. So therefore A is equal to 2. I hope you guys learned something new here. I hope you guys have learned something new. Let's get our feedback. Did you guys know how to do this one before? Onliners? Okay, Kenelli Sizwe, you are lost. Smiley face method, let me show it to you again. She said she's lost. So let's go to this one. Right, we need to find A. Watch here. I'm going to erase everything. I'm doing this again. Pay attention. Pay attention. I'm doing this again. This is for Kenelli Sizwe. Right. So we're doing B. We want to find A. So our equation is log AX. Log AX is equal to G to the X is Y. So log A, what's X? 4 is equal to what's Y? That's X, there's Y, is equal to 2. So now we need to remove the log. So to remove the log, we use the winky eye method. Winky eye. What's winky eye? There's your smiling face, and then you move that way. So where do I start? I start there. So let's draw it. There's your smiling face is equal to that. So A, start from your base, A to the power 2 is equal to, we're going across, is equal to 4. So A is equal to the square root of 4. A is equal to 2. Can you see where? Does that make sense to you now? It's a method that we use. It's a method that we use to remove the log. Are you following? Are you following? Are you following? Can you see where? Are you with me? Log base answer equals x. Yes, very good. The base to the power exponent is equal to the number. That's the method, the smiley face or the winky eye method. So now we got K and we've got right. You know what? I'm going to add on another question. H. Where is f dash x less than 0? So I'm adding on another question here. So we're done with that. We're done with that. K is 1. So we know K is 1. And A is 2. So I'm going to go there and I'm going to put 2. I found A equal to 2. The inverse of f of minus 1. So I'm answering C. Now we know y is equal to square root x. So the inverse of this parabola is x squared. So y is equal to x squared. The inverse of square root is squared. So y is equal to x squared. So I can say f of minus 1. F of minus 1x is equal to x squared for x greater than 0. The positive part of your graph. There we go. It's the positive part of your graph. The next question. Because this is your inverse. Of which graph? Of your parabola. So if the inverse is square root, or your original is square root, then the inverse will be a parabola. If your original is a parabola, then your inverse will be square root, because the opposite of square or the inverse of square is the square root. Right. Where is g of x greater than 0? Where is g of x? Where's graph G? Let's highlight graph G. Where is g of x greater than 0? Above. It's above there. So for all your x values greater than 1. Not equal to. You can also say from 1 to positive infinity. Let's do E. Where is g of x less than or equal to 0? So it's less than, it's below your x-axis. Graph G is below there. But it stops here because that's your asymptote. So for all your x values less than or equal to, because they got an equal to sign, 1, but greater than 0. Don't put an equal to. You leave out the equal to because your y-axis is your asymptote. That's why I leave the equal to out. You don't include the equal to sign. Are you guys following me? Onliners, are you still there? Are you still focused? Are you still focused? All
Yes,
hands on deck.
they're still vibing with you here. See the
Are you
smile
guys
here
still
from
vibing,
Miss
guys? Are
Karim.
we vibing?
Yes,
Anis.
he's still vibing, yes, definitely.
He's still
I'm still
vibing.
eating, I'm still having lunch, Mr. Kota. And I think
I haven't
I may
eaten
have,
yet.
yes,
I
I
haven't
haven't,
eaten yet today. It looks like
okay,
I'm
so,
fasting on my energy drink.
yes. So my
I'm boosting
apologies
here,
if any
bruh.
of the
I'm boosting.
learners pick me up chomping on my pasta here in the microphone. My sincere apologies. I have muted myself since then.
You had to tell us what you're eating. Ne?
Eating rabbit food.
Rabbit food, bruh. Rabbit
Yes,
food.
some healthy for me and you, so I can carry both of us.
Yeah, you
In
can be
case
healthy
you,
for me.
yes, I can be
Right.
healthy for you.
We did D. So we did that. We did the inverse. Greater than, less than. We are now doing F. Sketch the inverse of F. So F was what? So basically, we're going to sketch F. But this is only the positive part of the graph. So remember, your entire parabola would look like that. That's the negative part, and that's the positive part. We only want the positive part, so we do that. That's f of -1. The positive part of the positive inverse. The positive part of the positive parabola. That's what we sketch. The positive part. In fact, you don't, I just did this to show you what to do. We leave that out. Don't even show that in your exam. That's 0. Much more to come. In fact, tomorrow morning, we're starting with trigs. First thing in the morning, we're starting, while your minds are fresh, we're starting with double and compound angles tomorrow. And I'm choosing a hectic paper to work with you tomorrow. So that's out. That's out. The equation of the asymptote of G. G is your log graph. Asymptote means a line which your graph never touches. Asymptote, a line which your graph never touches. So let's answer that one. The asymptote of G. So which is graph G? G is your log graph. There's your log graph. Which line will this never touch? It will never touch your y-axis. And what is the equation of your y-axis? X equals 0. Don't just put y-axis. You'll get it wrong. The equation is x equals 0. Now the next question. Where is, I want you to try this one on your own. Where is f dash x less than 0? Where is f dash x less than 0? Right? I'm erasing this. I'm erasing that. Now, f dash x, there's f. What does dash mean? F prime x, it means the derivative. So I'm just going to redraw it because it looks very hectic there already. Relax. Don't panic. Don't stress. I'm just going to do it again here quickly for you. So you got that. You've got that. And you've got that. And that is graph F. They want to know, the question is, where is f dash x less than 0? Let's see how you do that one. This one is going to beat most of you. This one is going to beat most of you because I know what most of you are going to do for this one. For the last one, I know what you're going to do. You're going to try and find the derivative. Wrong. So where is f dash x less than 0? It means, this means, where is the gradient of the tangent to f? Less than 0, negative. That's what the question means. Don't go trying to find the derivative. Don't try and find the derivative. So all we do is we draw a tangent to the graph. And we know this tangent has got a negative gradient to infinity. That's minus infinity. That's positive infinity. Where is it negative? For all these values, but be careful, it's got a restriction. It stops there. That's a turning point. Remember this graph here. How would this graph have gone? How would that graph have gone? That graph would have went like that and went like that. So it stops here. So remember, to find the gradient, change in y, we're going down, is negative, over change in x is negative. Hey, sorry, this one's got a positive gradient. This graph f has got a positive gradient. Negative divided by negative is a positive gradient. So where is f dash x less than 0? For no values of x. Because this graph will never have a negative gradient. No values of x. If the question was where is f dash x greater than 0, then you would say for all your x values greater than 0, not equal to. At 0, it's a turning point. So the derivative there is 0. So it's for all your x values greater than 0. So please learn these two. This graph, to repeat what I just said, this graph f, so let's erase that. This graph f will never have a negative gradient. That tangent is positive always. From negative infinity to positive. So it will never have a negative gradient. This part of the graph. So if the question asked you for which values of x will f dash x be negative? For no values of x. Why? Because it, and they might even ask you why. You'll say, because it will always have a positive gradient. Will always have f dash x. In this case, will always have. So let's put here, will always have. So f dash x will always have a positive gradient. Right? Where's Kota? I saw another Kota here on the group. Where are you from? I got family, I don't know. And where is f dash x greater than 0? Alhamdulillah. Luandile Baloi. Luandle Baloi. Hundreds, Lani, hundreds. And there we go. That brings us to the end of that question there. How about I give you an exponential graph? This was dealing with a log graph. Let's give you an exponential graph. You're going to be tested on this. 100%. Let's give you an exponential graph. Let's go. Let's clear the frame. Let's do an exponential. Let's quickly do an exponential here. Take this one down. Take this one down. Let's give you an exponential graph going like that. Let's call that graph H. Let's call this point R. That point is point R. Let's give you a point on here. I call that 3 and 5. Okay. So question number 1, and I tell you H of X is equal to A to the power X. Question number 1, find the value of A. Question number 2, I want H of minus 1x in the form y equals, I want the reflection of H about the y-axis. Number 4, sketch H of minus 1x for which value or values of x is H dash x greater than 0, H dash x less than 0, yeah, do this. There we go. Let's see if you can do this one on your own. Let's see if you guys can crack this one, if you guys can dala this one on your own.
So, Mr. Kota, lots of the learners have been wanting to know from which year's question paper you're basing some of these questions. Is this now like a
These
national
are
trade secret?
no, this is just national preparation. These questions are your most asked questions. You need to understand this. It's not every question coming out. It's what you need to know. What you need to know. If there's a question I've extracted from a whole variety, I'll give you guys a fantastic link to download past papers. In fact, I'll give it to you now. Relax. Let me tell you. You want to work through this one. It's called SA exam papers. Let me write this link down for you. SA exam papers. Now, guys, there are over 200 past papers here. Right? You can Google this. And it's got memos. It's got Northwest. It's got all 9 provinces. It's got the memos. It's also got your June papers. It's got supplementary papers for the rewrites. It's got final papers for all provinces. Magic site. Magic site. In fact, I can even take out, let's take out here. Can I show you something? In fact, I'm going to take out, after we do this one, I'm going to take out one from the Limpopo question paper, right? After this one. Certain questions, I'll tell you which paper it comes out from. Certain questions, I just won't tell you because, I've got so much of resources. So go to SA exam papers on Google. Just Google it. Brilliant. Let's answer this together, guys. How are we doing, onliners? Are we cracking it? How's the energy levels? Don't worry, I'm watching time. I'm watching time. I'm going to give you a killer question. You know what? Come, I give you a higher order question after this. The next one came out of is A equal 1? I don't know. Keep it in square root form. I don't have a memo here, so we're going to be working it out together. Listen to this. If A to the power 2x is equal to 3 to the power x plus 1, here's your higher order question. Find A in terms of x. Find A in terms of x for 6 marks. Ha! There we go. There's your killer question at the end. All of you working at schools, A 1,71 going once, 1,7 going twice, 1 and 1,7 it must be. Guys, do me a favor. Don't round. Don't use decimals. You're all wrong. Don't use decimals. We never use decimals. Hasanain, all good there, bro. How's our comments? Are they enjoying it? Are they loving our show?
Oh, definitely. It's focus. Deep focus now.
Alhamdulillah, they're working. They're sweating. Guys, what you say we go till 8 o'clock tonight? I'm willing. I'm game. I know you all need to run. Hasanain?
I'm going to run outside Beachester.
Yeah.
You want to go
Hey,
until
guys,
8 o'clock?
I'm willing to go the night before you write. I'm willing to go till 10 o'clock, 11 o'clock at night. No sleep, Baba. No sleep. No sleep.
And then what about your handwriting, Mr. Kauter?
Don't worry. I'll keep it as good as this.
I have to worry. You're doing very well now. Now, if you want to go until midnight tonight,
Number one.
then you're gonna be writing like a tortoise tomorrow.
Never. We're on fire. I did once. I told them in the last workshop, a 72-hour non-stop workshop. I didn't sleep for 72 hours.
Okay. And
So
your
why
handwriting wasn't affected? And your handwriting wasn't
look
affected?
at me, and there's nothing wrong with me.
I don't need any sleep. I'm okay. I'm
okay. There's nothing wrong with me.
I'm experiencing a caffeine overload from this beverage that I'm having. I don't know. What is it, the Blue Bull or something?
Guys, do not leave it as this. Do not convert to decimal. So basically, h of x is equal to cube root of 5 to the power x. Now you see where you're going wrong. You guys want to go and do your own things and convert to decimals. Now do you see where you're going wrong? You never say, no, you don't use decimal. Don't go and say 1,71 to the power x. No, you leave it as a fraction or leave it as a third. That's proper mathematical manners. When you convert to a decimal, you're becoming mathematically rude. This is etiquette. I'm teaching you how to behave in math. Yeah. It's like when you write, when you want to be mathematically rude or abrupt, then you go and write a number like x, you go and say plus 1x to the power 1. You are swearing your maths teacher. Don't do that. Leave it. Question number 2. The h of minus 1x in the form, so y equals log cube root of 5x. That's your base. Turn up the base. or turn down the base. Question number 3. The reflection of H about the y-axis. So about the y-axis, the graph is going to go like that. And we know that when we reflect something about the y-axis, the x sign changes. So h of minus 1x is equal to the cube root of 5. The x sign changes, minus x. Onliners, as Jalapopop, Double Dolly, Moja, Kway, Nga, Awe, Duidelijk. Point taken. Number 4. Number 4. Sketch h of minus 1. There. I just did it. Answers op 'n skit. Op 'n math skit. Op 'n math skit. Op 'n math high. Right. Sketch h of minus 1. There's h of minus 1. Of who? Al die mense van die Eldos en die Enedale. Of who? For which values of x is h dash x greater than 0? So what do we do here? Luister mooi. Luister. Maak julle ore oop. H dash x. So now we're going to draw a tangent to h of x. Negative over negative is a positive. So for which values will it be greater than 0? For any value of x. So the answer, where is h dash x greater than 0? This graph will always be greater than 0. The gradient will always be positive. So therefore, you can say minus infinity to positive infinity, or you can say for x being an element of real numbers. Where is h dash x less than 0? The gradient of this graph will never be negative for no values of x. Can you see? We're not going about trying to find the derivative. Be vase. I vase you. Make you vase here. Your Sunny. Mark your vase. We're here to make you vase. Gee, what's happening there?
Comment. We got a comment there, Mr. Kouter.
I didn't draw the inverse. Oh, I didn't draw the inverse. Okay. Sketch h of minus 1. Oh, okay. This was the reflection about the y-axis. So draw the inverse. The inverse. Oh, of h goes in this direction. Your log graph. And because they got a point here, 3 and 5, you've got to put a point here, 5 and 3. There we go. There we go. We're so excited here in studio. We're making some silly errors.
So right, we still love you, Mr. K.
Love you too.
Mr. Special K. Kellogg's.
Eat your special K.
Morning.
Every
Mr.
morning.
K.
Have your
Mr. K.
special K.
Got nothing but love for you, Mr. K.
Lots of love coming from Kway here to the rest of the country. Guys, my heart goes out to all of you. Passionate about math, passionate about you getting your distinction. If you never saw things before, I hope today and tomorrow is an eye-opener. I hope you see math in a different dimension. And I hope you tala, you crack it, you smash it. Like Khabib, I'm going to smash you. I'm going to smash him. And that point there is 1 and 0. Our log graph, this is the inverse. of exponential. As you can see, I'm a big Habib fan. How did you do the last one? If a to the 2x is equal to 3 to the x plus 1. Let's see. Let's crack this. And then we got 30 minutes left and we're going to do some sequences and see. Guys, I don't need to do the hyperbola with the shift in asymptotes. That's so easy. I don't need to do the parabola. You guys have been doing the parabola from grade 10, 11, and 12. Right. So we want, the question said find a in terms of x. So we need to make x the subject of the formula. Come guys, keep the comments coming. I hope you guys loving the show from all over SA, all 9 provinces, 250,000. I think we're not just breaking our previous record, we're just setting the bar very, very high. Alhamdulillah, world first. Now attach a log. So log a to the power x is equal to log 3x plus 1. Because we want to make x the subject of the formula. Bring 2x in the front. 2x log a is equal to x plus 1 log 3. What do we want? So now 2x log a is equal to, I can multiply this out, log 3. So it's going to be x log 3 plus log 3. Right, we want the x's on the same side. So 2x log a minus x log 3 is equal to log 3. I want x, so let's take out x as our highest common factor. We left with 2 log a minus log 3 equals log 3. I want x on its own in terms of x. So x is equal to, here's your final answer, log 3 all over 2 log a minus log 3. And that's your final answer. There we go. Higher order for you to manipulate the logs to make x the subject of your formula. Okay. Now, let's go into the last 30 minutes. G. Why? Find a in terms of x. You put x. Oh, sorry. Okay, find x. Find x in terms of a. The question right there. Find x in terms of a. There we go. Just make that small correction there. Find x in terms. So we're finding x in terms of a. There we go. Find x in terms of a. They wanted you to make x the subject of the formula.
Mr. Kota, I think your in-studio code or your class in-studio, they're definitely on the A game, right? They went early to
A game. I hope they better. I told them I want nothing less than 85% in their exams over both papers. Well, some of our A game students, the one got 98%, the other one got 99%. Alhamdulillah.
Well done. So, Mr. Kota, are we going to see some Mexican waves tomorrow?
Definitely, definitely. I better tell them. Now, tomorrow they're all sitting here with us in studio in here. I had to move studios, but tomorrow, because we didn't have a TV in this studio. So
No
tomorrow,
problem.
yeah, everybody will come in here. Then we'll
So,
show it.
the whole of Mzansi and the Department of Education, we're all going to be getting the gears going with some Mexican waves. Eh? What you say, Mr. Kota?
Why don't we do a Mexican wave now? And let's see all the different schools. And then, guys, from all your different schools, send the video through to Awqaf.
Yes.
Let's see. Let's see everybody does a Mexican wave. Are you guys ready? And then you send it through to Hasanain and Hasanain will aid. And let's see all the different schools, all the different learners.
So let's go.
So let's
All
go.
the classrooms across South Africa. Is it time for a Mexican wave? We're going to do the
You guys do
countdown.
know
Mr.
what a
Kelly.
Mexican wave is, no? You know what a Mexican
Yes,
wave is.
that's
Not
the
a
wave.
vuvuzela. I don't want you to make...
No, it's the wave.
Just do a wave. So we know that you are
So, Mr.
based.
Kota, just give them a countdown, a 3, 2, 1
Right.
countdown.
Are you
And
guys
the countdown
ready?
is
Are you
now.
guys ready? Let's do a Mexican wave, guys. In 3, 2, 1. Mexican wave.
Yeah.
Let's do it again. Let's do a second one. Take your cameras. Somebody take a video of it. Send it through to Hasanain. Send it. Hasanain, are they going to send it through to you on your WhatsApp?
Yes, or they're going to email it to me. Whatever
You can
the case
email
may
it to
be.
Hasanain or send it to, there's Hasanain's email address. And
Then
what's
send me
your,
videos.
send your videos to Hasanain at awqafsa.org.za, guys. Let's do one more. Let's do one more. Get your videos ready on your phone. Let's go again. In 3, 2, 1. Essay!
Yeah! I'm waving, man. I'm waving.
Yeah, you got that World Cup fever, Baba. World Cup fever.
Yeah, you woke me up there. I was falling asleep a little bit. I was dozing off. But,
Here we go, here we go,
yeah.
here we go, here we go. Clear the frame, clear the frame. So there we go. Right. I want to show you guys something in terms of the new quadratic equation. Please, guys, learn this next one. I did it on TV last week. I'm going to do this one again. Please learn this 72, 100, 120, 132, right? They tell you it's a quadratic number pattern. Please learn this one. Right. So obviously 1, 2, 3, 4. Find T5. That's easy. Find T5. That's the easy one. Number 2, find Tn, the general expression. That's also easy. The general expression. The next one. Find the maximum value. Find the maximum value of this pattern. And number 4. So that's your higher order question. That's your higher order question. A term in the above sequence is equal to the 12th term of the sequence. A term in the above sequence is equal to... Oh, okay. Yeah, send it to me and I'll send it to Hasanain as well. A term in the above sequence is equal to the 12th term of the sequences of first differences. Of the sequences of first differences. Find the position of this term in the quadratic sequence. Find the position of this term in the quadratic pattern. Right, let's go. Questions, answers. Go for number 1, go for number 2. Are they sending in all the videos there, Sanin?
Yes, I'm counting them, eh? It's growing at an exponential rate now.
I like the word. No pun intended.
Yeah, I'm a mathematics teacher here. Trust me. I'm a doctor. I have lots of patience.
I can see you got a lot of patience. To put up with me, you should have a lot of patience.
Ah, that's a story to tell, eh? I should write a book about that.
My censorship board. Hasanain is my censor. Am I behaving today, bro?
Yeah, no, film and publication
The
board
board.
won't revoke your license. So we'll just see. We still got day 2 to get through. So we'll see
No,
how
no,
that
I'll
goes.
behave. I
We'll
promise
see
you,
how...
I will behave. I will
Okay.
behave. And 132 minus that is 12. Am I right? Then 28 to get to 20. 20 minus 28. Minus 8. Minus 8. 12 minus 8 is 4. Ne? 12 minus 8 is 4. 132 plus 4 is 136. There we go. Right, find Tn, the general expression. Let's just double check. 12 minus 8 is 4. 132 plus 4, 136. So T5 is 136. Find Tn. Find Tn. I know you're going to use 2a plus b. A plus b plus 2a equals 3a plus b. A plus b plus c. Well, I got something new for you. Tn is equal to term 1 plus n minus 1 times your first difference plus n minus 1, n minus 2 over 2 times your second difference. I know you guys all sitting and looking and saying, what? Well, one formula. Okay, you do it your way. I'm going to do it my way. Let's see whether we get the same answer. Come, go Dala, go do yours. Do what you know. Yes, live session, Claudia. Tomorrow, live session. We start at 9 again,
9
but we
o'clock.
finish till 3 o'clock.
The
You
Mexican
see,
waves
you
are
came to
coming
Kway
in,
to
Mr.
make
Kota.
waves today. These are tricks of the trade. Yes, Asanay?
Yes, so the videos are coming in fast and steady.
Yeah.
So we'll probably have an opportunity perhaps tomorrow to play some of these.
To air the Mexican wave.
Yes.
Good.
Some
Term
here,
1. What's
wake
term
up
1,
the
guys?
secrets.
72 plus n minus 1. What's my first difference? 28 plus, this here is n squared minus 3n plus 2 over 2. My second difference is minus 8. 2 goes into 2 once. 2 goes into minus 8 minus 4 times. Tn equals 72 plus, I'm going to multiply that out, 28n minus 28 minus 4n squared plus 12n minus 8. Tn is equal to minus 4n squared. 72 minus 28. 72 minus 28 minus 8. 36. Am I right? Did you guys get, are we all getting the same thing? 72 minus 28 minus 8 plus 36n. No. It's 28n plus 12n plus 40n. And then 72 minus 28 minus 8 gives me minus 36. What's it? Plus 36. Come, onliners. Tell me you got the same answer as me. Did I get the same answer as you? Ghost. What sorcery? What sorcery is this? What magic is this? Well done, well done, well done. Like a boss. Well, you just did it differently and I did it differently. Razin, Amina, yo, mashallah. Yeah, okay, stick to ABC. You stick to what you know, I stick to what I know. Right, let's go back. Let's go back. Let's go back. Let's go back. Right, we're now going to answer, find the maximum value of this pattern. So let's go here. Let's go here. Let's find the maximum value. Right, watch here what I do. Whenever they ask you for the maximum value, I'm answering question number 3. Say dn minus 4n squared plus 40n plus 36 dn, and now say is equal to, for maximum value, we use derivative minus 8n plus 40. For minimum or maximum, what do we know? Derivative is equal to 0. Derivative. Calculus in number patterns, Baba. Calculus in number patterns is equal to 0. Minus 8n will equal to minus 40. Why 0? For minimum or maximum. Minus 8, divide by minus 8, n is equal to 5. So what is the maximum value? Therefore, the maximum value is minus 4 into 5 squared plus 40 into 5 plus 36. Here's your final answer. Let's do it together. Minus 4 into 5 squared plus 40 into 5 plus 36. Boom, 136. In fact, here 136 becomes your maximum. You know why? It starts dropping after that. This is a quadratic number pattern. It goes like that. It's a parabola. And your parabola's maximum value is 136. So you got 72, 100, 120, 132, 136. Now it starts coming down again. Did you know that? Your quadratic number pattern is a parabola. And now you sit there and say, okay, now I see. And if this was positive, then it will look like that. Then it will have a minimum value. So you'll have values coming down, 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 down to a minimum. Then it will go up, 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 up to infinity.
Question.
Geometric is exponential. Parabola or quadratic is a parabola. Well, this method of finding T and get us full mark because it's really cool and I want to start using it. Good vibes. 100% Baba. 100%. You want to show your teachers you are vase. Pagamisa. Kwalaga judge.
Mr. Kouter, what's happened to you, man? Are you sleep deprived or something? We don't talk like that.
We don't talk like that.
We don't talk like that.
We don't talk like that. We speak the Queen's English here.
That is the language of the prison.
Correct. That is Paul's mom, my bro.
Papa, wag vir jou.
Yeah. Jalous Bokkie. Jalous Bokkie.
Are you kidding me?
Swasal J. Jalous
Now that is exhaust
Bokkie.
fumes.
Jalous Bokkie. You know that song? They sing it in the prisons when they're sweeping the
Oh
floor.
my word.
Jalous Bokkie. Jalous Bokkie. Swasal J.
Oh my word. I think this is the lowest point of the Awqaf online maths workshop. God must just have mercy on us.
God save us. A term in the above sequence is equal to the 12th term of the sequences of the first differences. So what do we have? What were our first differences? Our first differences was what? 28, 20, and 12. Those were our first differences. So now Tn equals A plus N minus 1 times D. Your first differences is an arithmetic pattern. So 28 plus N minus 1, your common difference is minus 8. So Tn equals 28 minus 8n plus 8. Tn equals minus 8n. 28 plus 8, 36. So 36 minus, so Tn is equal to 36 minus 8n. Right? And what did they say is equal to the 12th term of your... Right, so 36 minus 8n. So this is Tn. So T12 is equal to the 12th term of the sequences of the first differences. So T12 is 36 minus 8 into 12. So T12, do not equate it to 12. So now what do I have? 36 minus 8 into 12 minus 60. So now what? Find the position of the terms in the quadratic number pattern. So what did we have? We had minus 4n squared plus 40n plus 40n plus 36 is equal to minus 60. So minus 4n squared plus 40n plus 36 plus 60 is equal to 0. Minus 4n squared plus 40n plus 96 is equal to 0. You can use your quadratic formula or your silver calculators. N will equal to minus 2 or n equals 12. N equals minus 2, but you know your number of terms can never be negative. So therefore, n is equal to 12. You guys check how we slat it. Grade 12s. Did you check how we slat this one? Right. We got about 7 minutes left. Let's give you a sigma notation quickly to do. No. Not a sigma for now. In this time here, let's give you a higher order. Which one was it? Here we go. Let's wrap up today with the next one. Next one is Kway. You're going to smart the next one, bruh. I'm clearing the frame. Come, bruh. Tomorrow morning we are fresh, ne? 9 o'clock on the dot. We're pulling till 3 o'clock tomorrow. So better make your transport arrangements. The sum of the first two terms of a geometric series, the sum of the first two terms of a geometric series is 4 times the sum, is 4 times the sum of the next two terms. if the sum to infinity is equal to 3, question number 1, find R. Question number 2, find the first term. So we're going to end up with this one. I might start off tomorrow with another couple of higher order sequences and series questions just to get you guys varam, and then we start again. So this one here is worth 4 marks. That one there is worth 2 marks. Total marks 6. How are we doing, onliners? Having a good time doing maths. You guys never thought you'll have so much fun doing maths, right? Yeah, ne? Hawa Kareem, don't worry, we're seeing it. Don't worry, Hawa, we're seeing it. Maslodi, Rebecca Mantata. He's gone. Mr. Madau is coming tomorrow. I'll see if I can. Zayan is a silver calculator. No, it's not illegal. Some schools will allow you to, some schools won't, man. If they allow you, take it with you in. If not, you have to use a quadratic formula. Sorry, ne? Askis. But there's no rule, there's no official law to say that that silver calculator is not allowed in your exam. Right, let's answer. We're going to wrap up now, guys.
How's this comment on
me
the
see.
screen there? Especially for
If you see this comment, you owe me a Gads. I'm not in Cape Town. Send the Gatsby, bro, from Golden Dis in the Cape.
We don't talk
Send
like
from
that,
Golden
Mr.
Dish,
Culture.
bro. Send the
We don't
Gatsby
speak
there
like
from
that
the
at Cape
Rylands,
Town.
from Athlone. The
That's
sum of the
like
first 2
uncool.
terms of a geometric series, so A plus AR, is equal to 4 times the sum. So your first term is A, the second one is AR1, the next one is AR squared, the next one is AR cubed, the next one is AR4, and it will continue like that, right? So the sum of the first 2 terms of the geometric series is 4 times the sum of the next 2 terms. 4 times the sum of the next 2, AR squared plus AR cubed. Right, find R. So we take out A into 1 plus R is equal to, so we got 4AR squared plus 4AR cubed, if I multiplied it out. So A into 1 plus R is equal to, let's take out 4AR squared as my highest common factor. I'm left with 1 plus R. Now we divide this side by 1 plus R. What I do on that side, I do on this side. So now I divide by A and I divide by A. So A divided by A is 1 equals 4R squared. So 4R squared is equal to 1. R squared is equal to 1 over 4. Therefore, R is equal to the square root of 1 over 4. R is equal to a half. And that's the answer to that one. We come to the last one for today. Find the first term. Find the first term. They told you S to infinity is equal to 3. So S to infinity, if R equals a half, is equal to A over 1 minus R. That's your formula. Listen to me. Question. Does it converge or diverge? They could ask you the next question. Does the above series converge or diverge? Why? So obviously it converges. Because r is a half, I'm just going to answer question number 3 here. It converges. Because r is less than 1 but greater than -1. A half is less than 1 but greater than -1. That's the answer to question number 3. Please, they love this question. Learn. So s to infinity 3 equals a over 1 minus r is a half. So 3 equals a over a half times 2 times 2. So 2a equals 3. I'm moving over to the side, guys. I don't have space. 2a equals 3. A equals 3 divided by 2 is 3 over 2. And there we go, we're done. The last question, there's the answer for question number 3. Does it converge or diverge? It converges because r is less than 1 but greater than -1. And there we go. It is 2:30 on a Saturday. Don't go and skip tonight. Do your work, study. You guys are writing English. What you guys writing? The life of pi. You guys writing the life of pi.
Okay, Mr. Kouter, that also applies
Yeah.
to you. No? You need to get early to bed. I'm also going to do
I'm
the
going
same
to
thing.
skit. Yeah,
You
I'm going to
mustn't
skit.
skit your biscuit there, Mr. K. Must
I'm
keep
going
your
to
biscuit in the container. You
Old
can
people
skit your
like me,
biscuit.
we biscuit. Light is
Yes.
skit, we biscuit.
Yeah.
Okay, assalamu
So that's
alaikum. Good afternoon. I hope you guys like the show. Send all your comments. You guys know, I'll tell you guys again, please remember next week Thursday, next week Saturday. So yeah, share some videos there, bruh.
Okay,
Share
let's
some videos.
play through that there. So you can just
Let's play
like
through it. Right. Salaam alaikum. 2 plus 6 divided by 2. 2 plus 6 is 8. 8 divided by 2. See you guys. Salam. Fantastic, fantastic, fantastic. Get your videos ready on your phone. Let's go again. In 3, 2, 1. Essay!
how's that for a one-man Mexican wave? I think
One man
that is
show, bro.
definitely-
One man show.
Yeah,
Mashallah.
this is
Check
the
at that,
more
man. Check at that.
content highlights.
Beautiful, guys. Beautiful, beautiful. Love the
Intense
vibe, love the energy.
concentration. So on our Instagram, I have posted the YouTube link, the link in the bio. So people can access it. You can go onto the Awqaf's website. Let's show you that quickly.
Link in
There we
bio.
go.
I smart that one. Link in bio.
Link in the bio. That's a high grade question. So that's the Awqaf SA website, awqafsa.org.za. If you go onto the homepage, this is the homepage of the Awqaf website. What you do, you scroll down or you go to this one, this banner will take you to the maths page. So this will load the event page over here. And you see this is a YouTube video. If you click on that, then this will take you to the live stream. So we're actually watching ourselves.
I check myself, bruh.
Yes, you're famous. You are famous, Mr.
We are
Kouter.
famous.
So,
We are famous.
So please send us some more photos, your feedback.
Send
so
us
we
all
get
your
the
comments, send
feedback,
us your photos,
so
send
we
us
can
your
get some
videos. We'd
more
love to
of
hear from
Mr.
you.
Kouter. So we can get some more of Mr. Kouter on there. And this is the web address. So in conclusion, Mr. Kouter, tell me, how did day one go today? Maths paper
Wonderful.
one. How did it go for you?
Alhamdulillah. I wish I could do so much more, but we have so little time. Time is always against us, but as long as they know what to do, how to apply the formulas, and we've done most of the styles, the easy stuff we've left by the wayside. We just do the ones that want to get, that they need to get prepared for the big fight, title fight. next week Friday, and the following Monday.
Okay, so I'm just going to scroll through some
Michael,
of
yes,
the-
let's hear some of the comments. Lovely, lovely. Alhamdulillah, Tebatso, thank you, thank you, thank you. Skim Sam, Lemon Stacks, you enjoyed it.
So I think that, Mr. Kota, with your efforts, we're gonna get a few engineers, a few doctors, a few lawyers, accountants, and I think the future looks bright. I think with your
Come, guys, we can do it. We want to see engineers, we want to see doctors, we want to see presidents, we want to see ministers, we want to see architects.
But it all starts with
Boys Eyes,
mathematics.
Zayan Jadin, Adil Durani, Onatando, Lwandile Baloy, Lilita, Nokutaba, Tiniko, Headshot. Poof. Sitembelen Gubani, Ronel Pelman, Bronadine, Mohammed T. Show us ways, Uzwati. No, next week. Don't worry. You guys can start booking from Monday. Don't trouble me this weekend. You can start booking for next week, Thursday and Saturday from Monday. But guys, love you lots. Lots of love from our Joburg studios. Pagamisa. Assalamu alaikum. Salute.
Wa alaikum salam wa rahmatullahi wa barakatuh. So we would like to extend a warm thanks to the complete or whole Awqaf SA team. We would like to thank the Department of Education for the assistance. We'd like to thank Mr. Kota for his energy in delivering maths paper 1 today. We will be bright and early tomorrow at 9 in the morning. awqafsa.org.za. You can log on there. We'll be hosting the putting that link of video of today and tomorrow as well. So we'll see you bright and early, and this is what the program looks like for tomorrow. So I think we will have some carryover, 1 or 2 items we didn't deal with. So yes, we look forward to seeing you tomorrow, bright and early, 9 o'clock. So try and log on a little bit earlier, and then we can try and see how we can assist you. Let's do this. So thank you to you, the learners, as well as the schools, the dedicated educators that have logged on today. Thank you so much, and then we'll see you bright and early tomorrow. Thank you so much.
When we take care of each other, wonderful things happen. Children thrive, the elderly rejoice, communities celebrate. Awqaf South Africa, a charitable Waqf receiving organization, makes it easy to share the care. All donations are plowed into Sharia-compliant investments, while the fruits support a great variety of charitable causes. Visit the Awqaf South Africa website at awqafsa.org.za to discover how your Waqf can bless our community with the legacy of care. Awqaf South Africa, share the care.